All right. I think we should have somewhat better audio levels for this stream than last time. It could have been the cat's fault. It could have been my fault. I'm not quite sure, but there was definitely a knob that was turned much lower than it should have been. So I think we should be better this time. So welcome back to the stream. I can see Tuco from where I am. He's a little far away, but let me see if I can get the camera on him anyway. Oh, I think that camera is having a slight technical problem. Let us reset this camera. I should probably find a better camera to use for TucoCam. I keep saying that every time it has autofocus problems. This is one of those little LifeCam Microsoft HD webcam things, which seems alright, but I can barely see that to aim the camera. Alright, I think that's going to be good enough for now. So, welcome back. Today is a bit of a continuation from last night's stream, where I was working on something that's a bit of a side project, but also something that I can use for kind of fabrication-related footage in an upcoming video, and it'll be a useful just thing to have around the shop. So I'm making a little kind of a flexible button pad that I can use to switch between cameras on the stream, and then it'll be magnetic, so I can stick it to one of these curved lighting poles that I use around here. So I was just checking on the YouTube stream. Looks like things are up, and view meters are good. Cool. So on the last stream, we kind of did the initial design for this. I kind of came into it with this little mock-up that had, this is a teensy microcontroller, and this is just something that's convenient to use for emulating USB devices. This definitely could have been a project that uses just sort of a raw microcontroller instead of a, instead of an easy-to-use board like a teensy or an Arduino. And I went back and forth on this a little bit. I think some of the reasons. Oh, that autofocus. Do I have a teensy board here also? Or, sorry, a trinket? That's a teensy. Let me grab the other one that I was planning on using, which would be good to have for comparison. Yeah, so the reason behind this really. Not sure if I filed the trinket with the Adafruit stuff or with the microcontrollers. I think it's with the microcontrollers. I want to avoid getting too deep into explanation while I'm rustling through stuff in case I decide to use some of that audio. I had the the trinkets in some place where they weren't especially safe, and I think I put them in a new anti-static bag, but now I forgot where I put that anti-static bag. Oh well. Oh, is this it? This isn't the one I was looking for, but this'll do. So This is one of the other alternatives I looked into. So this one especially, just looking at the circuit board, it seems like it would be pretty easy to replicate this circuit on the flat Flex. So this is just a small microcontroller that I think it was Adafruit, it was their attempt at making really the smallest and cheapest thing that they could that was still programmable over USB. So I think this accomplishes it by using a software USB stack. I think it's the VUSB stack on this ATtiny85. And then the USB port is just connected to a couple of the I/O pins. And they use a fancy bootloader that I think it emulates a HID device. Anyway, it's pretty interesting. And I was able to get it to work fine as a keyboard emulation on some of my computers here, but then it seemed to have problems with some USB hubs and like some versions of macOS. So I could track that down, but I decided for this project it made a little more sense just to switch to a different microcontroller that had kind of a slightly more spec-compliant USB stack. And so this is a Teensy 2.0. I think this is based on the Atmega 32U4, which is a pretty great little chip. Yeah. So it's an AVR, but it has a built-in USB stack, and the teensy additions to the Arduino IDE make it pretty easy to program this thing to do various HID emulation or emulate MIDI devices. But again, like, that's convenient. We didn't necessarily have to use something like this. There is a kind of a more pragmatic reason, other than just, design expediency even, to use a separate circuit board for the microcontroller though. I want something actually kind of rigid, like right where the USB port is, to provide some mechanical reinforcement there. If this was attached directly to a flex circuit board, then that would be really prone to break, and I would have to make really sure that my 3D printed enclosure did a great job of kind of distributing the force as early as it can from this connector without letting it go directly into those solder joints and just weaken the board there. So having a nice strong fiberglass board right around the connector is kind of handy anyway. And it also means that we can have more than one layer without having to do a multi-layer board for the entire flex. So it's pretty easy to lay out the actual button matrix using a single layer. And then my plan is to basically make a lamination here. So if my finger here is the flex, then I would just kind of lay it up against those pads here and just solder through kind of surface mount style, so that this is then kind of bonded to the flex. And so that overlap would be a potential weak point. I'd want to make sure that the 3D printed surroundings kind of protect this area as much as they can, but it means that as long as I can support this whole circuit board really well in the 3D printed enclosure, and again, the 3D printed enclosure is also going to be flexible, so it can't necessarily support things, really from, with the flexible material, like I can't just kind of unilaterally support it from a point with plastic. I can't just kind of solve the problem that way later. I have to think about how to make this entire structure kind of, how to smooth out the variations in materials as much as I can to avoid weak points. So this is my solution for now, is to use the Teensy. So on the last stream, I designed so we started a little bit of the 3D CAD, and I've been doing that in Rhino so far because it's a CAD tool that I like. It's not really what I would prefer to be demoing on video because it's kind of an expensive commercial tool, and I'd rather show people how to use tools that are easy for anyone to use. So it's not optimal for that, but it's something that I like, and I thought it would be expedient for this particular project, since the parts of this project I'm more interested in sharing are the flat circuit board machining and the assembly, because I think that's just going into a video about, I think the design part is not necessarily something I'm going to focus on in the documentation, rather than I plan to use that as supporting material for the other stuff that I'm focusing on. So the mechanical design is sort of the why, and why I want kind of a custom flex thing prototyped, and then the how is, well, there's this material and you can process it in various ways and then we can assemble it. So maybe material is a good place to go next. Let me get my coffee and materials and catch up on chat and open the CAD on this machine. Hello, everybody. Oh, I guess Kenneth on chat is suggesting an epoxy potting. I'm not quite sure what that was in reference to, but I am thinking about how to glue this together because there's going to be kind of 3 layers, 2 3D printed pieces with made out of something semi-flexible, and probably printed so that the inner sides were both the flat build plate, and then I kind of build up like buttons on one side, and then I build up probably something else that turns out to be flat on the other side. The other side will probably end up looking boxy. Or maybe I do it the other way so that the back side is on the build plate in both places, so that I have a hollow on the bottom. Anyway, that's later. So anyway, I was thinking about how to actually attach these pieces, and I think my best bet might be to use E6000 adhesive, which is something I've got a bunch of around here because I've used it for some other projects. It's really strong, and it bonds pretty well to, I think, the materials we're using, and it's a little bit flexible even when it's fully cured, which is going to help in this case. I still think I want to be sure to use small amounts of the adhesive, but having an adhesive that's somewhat flexible is certainly going to help when you're gluing flexible materials. All right. There's this plugin I'm getting an error with, and I don't remember what this plugin even was. I'm going to stop loading it. Wake up, keypad. Huh. So this project is intended to be a replacement for this keypad, which I was expecting to work, but maybe... is there some kind of keyboard focus issue still? Huh. Oh, what's wrong with this thing? So I can switch channels, but my hotkeys are not working on here. I mean, I might have messed with the configuration somehow, but that doesn't seem likely. Let me try unplugging this USB device and plugging it back in. This would be a great time to have a more reliable button pad for switching channels, wouldn't it? Well, maybe I'll use this one until this starts working again. I did take this apart. I don't know if it would be interesting to do that on a stream. Maybe we will if folks in the chat are interested, but I took this apart because I was interested in mounting magnets on the inside of the case, so I wanted to see if there's room there. And it turned out to not be great in there, so I ended up mounting them on the outside anyway. But on the inside, it's kind of interesting. It has one of those flexible circuits the way you see inside keyboards most often, like printed on plastic with some kind of conductive ink. And then a little tiny circuit board, a little wireless transmitter, a little epoxy blob, and the contact between the board and the flex circuit was interesting. Oh, well, it's switching. Okay, so it's working without numlock. I think this might be a software configuration issue with the hotkeys, actually. I don't know how my OBS hotkey settings got lost, but anyway. This project is intended to try to obsolete that whole mess, so I'm not going to worry about it too much. I'm just going to use this to switch. Anyway, I was trying to get back to the computer, which is here. Oh man, there's some crazy lens flare going on with TucoCam. I wonder if I can get a better view. Tuco's like, what is this thing you're putting near me? Alright. Hopefully I won't trip over any of those wires. Okay. So this is what we had in the design so far. The shape here is the product of a couple of different constraints. Excuse me. So the overall size was dictated partly by the size of my mill. So it has a usable bed area of I think it's 4.5 by 5.5 inches or so. So that forms, I think, like this edge and this edge, for example. But then the width here is kind of I just was playing with a piece of cardboard or kind of thick paper, and that just seemed to be the widest width I would want to try to kind of curl around one of these light poles. And then these arcs here just seem to be a nice layout for the buttons based on, kind of having your hand in one position and kind of moving your wrist to pick different settings. So these lines are largely guides that I'm going to use to make the rest of the 3D printed case. Another of my goals for this project was to have more kind of tactile uniqueness for these buttons. So, the left, right, and middle button in each row will probably have, they'll be pretty easy to identify anyway based on their position on the pole, but I'll probably also have kind of a slope in the case so that, the buttons are angled a little differently and it's easy to tell the difference. And then each of these rows I might texture a little differently so that it's easy to tell the rows apart. Because I'd like something that's pretty easy to use even when I'm not really paying attention to it. And so most of this is placeholder geometry, but these lines on the XY plane here I exported to KiCad to do a circuit board layout. And here's our kind of lo-fi mock-up of the teensy board, kind of overlapping here. There'll be a little bit of a space there for solder joints, but that's roughly how it'll line up. And then kind of an example model for our tactile switch. And these should fit just so on these footprints that should, I guess these are just like this is a flattened version of this part that I then exported to KiCad, and then it matched up with some footprints that I found in the library. So on the last stream, I got this mostly done in the circuit board layout stage, but there's one change I want to make. So let's go back into KiCad. And I actually want to go modify the outline for the board. So I'd been thinking about, instead of just having this be a rectangle, actually have it be kind of a zigzag shape with some cutouts that allow it to be more flexible in 2 dimensions. And I don't really know how well this will work, but it seems like a good idea. And I designed the circuit board layout to follow a zigzag pattern around this way to make room for removing material in the Flex PCB to make the Flex PCB into kind of a zigzag. So I have the traces following that pattern, but I hadn't actually adjusted the board outline. And I was kind of assuming last time that I would just actually cut that with scissors or something after the fact. But I think I'd rather carefully design that part, partly because I want to use that shape later in the 3D printed part, and partly because that's actually one of the benefits of using a milling machine for this. Like, in a lot of ways, working with the Pyralux on a mill is kind of annoying, and it might be easier to chemically etch it, but one of the benefits is I can cut a really accurate outline, so I might as well use that and have the outline that I want. So I think I'm going to try to export the traces I have from KiCad back into Rhino, and then do the outline there, and then export the outline back into KiCad, since I don't think I can easily edit lines and polygons and stuff in KiCad. At least I don't see an easy way of doing that. So here's the PCB we were working with. And so this yellow layer is what the mill is actually going to cut. And so that's fine, but I actually kind of want to remove as much material now as is practical, because this material is limiting its flexibility. And if I can especially remove some of these constraints where you have big, square patches of material, those are only going to want to curve in one axis at a time. So if I can try to kind of linearize this as much as possible, then it'll be more flexible in general. And I might try to push some of these traces a little more to achieve that end. So the key combinations and stuff for the push and shove router are super unintuitive, but I think I mostly got this under control in the last stream. This is one of those programs where I spent a lot of time with it on one or two occasions, but haven't used it on a consistent enough basis to get really familiar. So I think the deal here is I think I want to be in routing mode. And then there was something I did to select a trace, but not start a new trace. Yeah, control click. So, and I think I just want to, as much as the constraints we have allow, I want to try to get some of these tracks a little closer together, at least in places where I'd want to trim material. So like here, for example, I can trim. And there also might be opportunities to optimize this a bit by changing where the resistors are, but keeping the resistors in line this direction is actually going to be kind of nice, because then the board will be easier to curl along that axis. And in fact, I should reorient this resistor to improve the flexibility also. I mean, it doesn't matter so much because it's so close to the teensy, but still, the more this can help transition between flexible and less flexible, the better. So how do I delete this easily? I guess I just press delete. Which delete? I think this is one of those operating system disagreements. Okay, that delete. It wants not the clear on the numpad, but the one labeled delete in the cluster over here, which I'm glad I have on this keyboard. The keyboard I usually use doesn't have that key, so I think I often forget to use that when apps ask for it. I'm a little worried about this resistor. I think I'm going to look for a larger value, because I don't think 47K is going to be large enough. That was just the largest thing I had handy. But if I can find like 100K, that might be nice. All right, delete. That looks nicer. Right. There are a lot of weird choices that many CAD programs make, and I think one thing that KiCad does that often trips me up is that many of its commands are just sensitive to not like what's selected, but like what's actually under the mouse. So this thing where you're using the mouse and the keyboard as modifiers for each other it's like really useful, but CAD programs all tend to do it in a kind of different way. Let's see, control. So yeah, I'm just going to tidy this up a little bit and then export this to Rhino and make a nicer outline that's actually worth milling. Hello, train. I think I just want to reroute this. I imagine there's probably some art to optimizing traces on flex circuits to be the most flexible and to wear the least. Maybe that matters less when you're working with really high quality materials. There we go. There's some mode switching too, so I have to exit routing and then delete the track I want to delete, and then I can get back into routing and then place the track in somewhere new. And then use Control-click to make things move around. Just checking to see if my screen recorder was going. It'd be really silly if I didn't remember to start it. Yeah, like that's much more what I want. Kind of a nice flow of traces. I guess that was fine. Well, actually, it'd be nice to move this a little closer so I can remove more material. Ooh, look at that. Oh, this would be a good time in the stream for like a musical outbreak of some sort, or possibly some kind of cat-related question and answer session. I don't know. I'm a little loath to get, like, there are some things where clearly my intuition doesn't quite match up with the rules that I've given to the design, to the DRC engine. Because, like, I'm moving this, and I actually would prefer to keep that a little further away from those pads to make it easier to hand solder. So maybe that just means I should increase the pad clearance. But I find myself doing stuff like that by hand a lot instead of telling the tool what I actually want. And then I look at it again and think, oh, maybe that's fine. And then tweak it a little more by hand still. the air wire is like, don't you want to go that way? And I'm like, no, I know what I'm doing. I'm doing this the hard way. Just watch. But yeah, this will make more sense once I actually start cutting away that portion of the board. Until then, it'll just look really strange to anybody who's just coming into the stream now and like, why is she routing that trace out into the middle of nowhere like that? Why is it snaking all over the place? And I'll just have to be like, trust me, this will do something useful eventually. Ooh, these wires very easily get kinky. And it's hard to unkink them sometimes. I mean, yes, my grid is like 1 mil right now because these parts are not, like none of these parts are on a grid, so I don't really see the point in working with the grid right now. These can be a little closer. I mean, it's nice to keep things kind of roomy right where you're soldering, because that's where it'll be harder to keep the signals separate because of solder bridges and stuff, but the rest of it, you're really just limited by by the milling tool I'm working with. And I set the clearance here to be generously larger than the size of my milling tool. So, like, if the DRC says the traces are a fine distance apart, then it's probably going to look fine once I actually get it over to the machine. Whoops. Let's redo this trace a little bit. I think I might want to, like, I don't want to have this like quite as close to that edge if I can avoid it. Let's also remember to save things, because, software can always crash. Oh, I just saw a question in the chat about why my cat Tuco is called Tuco, and I'm actually not entirely sure why. I kind of know roughly. So I mean, I didn't name him. I adopted him when he was about a year old, a little over a year, and I think he had had a couple of previous caretakers before I met him, and I think 2 of them previously. I think the person who had him before the person who had him before me named him. And so I don't know the full story, but he's named after the character from Breaking Bad, who's like kind of crazy and dangerous and totally the opposite of Tuco's actual personality, my cat. So I think it's kind of a funny, kind of a funny contrast. And, I could call him something else, but, it seems like an okay name. And he, I guess he responds to it as much as he responds to anything I say. Can I undo that? I didn't really want that trace to snap back up there where it did. There are a couple of these that are making me unhappy. I'm just going to delete the ones that make me unhappy, and then we'll see what's left over. I can do some more routing. That seemed a little better. There are so many annoyances in pretty much every EDA tool, but I certainly like aspects of this router. Like, there will be plenty of annoyances that you still have to kind of plow your way through, but once you get to the point of being able to use the push and shove router, I really like it. Oh, I think I need to leave a little bit of room, but that's fine. Mostly what I'm trying to do here is, like, I know I can move the traces easily, but one thing that's kind of harder to do with the push and shove tool is to kind of change the shape of the trace. So I'm trying to be a little more careful to shape things the way I want. Oh, is that the maneuver? I think I just managed to drag a new corner out of an existing corner. I think there was some kind of trick to that. I feel like this is one of those user interfaces that's actually much more gestural than it lets on. Oops, there's a little stub there. I should hang on to that. Okay, so that's an intentional bridge. I mean, I'm using the switch as a jumper, so there's going to be an air wire left over there. What else? This thing. So, since normally I would know I'm done because it's kind of under the on-screen displays right now. So down here there's information kind of in real time about the design rule check. So it's telling me I have 7 unconnected nets. Oops. Sorry. Don't even know how I did that. So it's telling me I have 7 unconnected nets. So I should actually be able to go around and find 7 of these little gray air wires that all just kind of cross over something that's connected by one of these switches. There's probably some tricks that I can use for that. Like, one thing I've done in the past when making single layer circuit boards that I plan to add jumpers for in the future is I'll have a second layer for those jumpers that I just don't plan to manufacture, but I use that one for DRC. But then you still have vias. Anyway, how can I scroll this without... Okay, the scroll wheel on this mouse is very sensitive. But if I middle drag carefully, we can pan this. Okay, so we have 1, 2, 3, 4, 5, 6, 7. Okay, so it looks like everything's reconnected. And I'm just going to squish these traces back together a little bit. Quiet camera. Oh, so maybe this is a good time to talk a little bit about the milling setup. So, I mean, so as I mentioned, this material is a little bit annoying to mill, but you know, you still then retain the advantages of milling, which is to say, it doesn't require a lot of, you know, it requires a milling machine and it requires maybe some trial and error, but other than that, it's actually a pretty clean and easy process. You don't have to mess around with chemicals. You don't have to have a laser printer, which I don't have here. But there are plenty of other ways to make circuit boards. This is just what's convenient for me right now. But one of the things that makes milling this material so hard is, unlike FR1, where you have a relatively thick copper layer and then a relatively thick epoxy layer under that, with this, everything is just so thin that you have to be pretty careful about milling just the right amount of material away. And to achieve that, you need a surface to mill or to attach the material down to, which is very flat. So I'll have to show you my my previous experiment in milling Pyralux. it was a smaller board. It was a little JTAG adapter for a microcontroller reverse engineering project, and I wanted to make something that would, break out a bunch of signals and stay out of the way, even with a bunch of other stuff attached to the board. So making my own Flex seemed like a good kind of challenge / solution for that problem. All right, let's close. But with that board, it was relatively small, and so I was able to fit it between the kind of screw holes in the spoil board on my mill. So I'll have to show you, but my mill isn't entirely flat on the bottom. It has some holes for recessed screws that attach the kind of aluminum plate that is designed to be relatively sacrificial. It attaches that to the actual structure of the milling machine. And so what I was doing is I was just picking a flat area on there and just literally gluing the Pyralux blank circuit board down to that. And so it's this very thin material that's a sandwich of copper and basically Kapton tape on the other side. And do I want to do anything with this? Oh yeah, I think I pulled out another corner. However I did that. Ooh, neat. Yeah, I think that's the trick. So yeah, I just picked out a flat area on the bed of the milling machine and used glue stick and a squeegee to get the material down there. Because the bed of the milling machine is going to be very level as far as the machine's concerned, because it was faced by the machine itself. The problem with that, though, is this project is a much bigger piece of the material, and so I'm going to need pretty much the whole surface of my milling machine. And I think I'm going to need to put down another material, basically a second spoil board on top of my mill spoil board, and then face that so it's very flat. So I've got a couple of different materials we can try. The thing that's probably most likely to work is acrylic. HDPE is also an option, but I'm a little worried that the HDPE is so, very few things stick to HDPE, so the glue that I was planning on using to attach the Pyralux material, I don't know if that'll bond to HDPE. I'd probably have to do a test on that. Could also use more blank circuit board material and just, stick it copper side down and then mill away some of the fiberglass, or not fiberglass, but mill away some of the epoxy on top to be a flat surface. But really, I'm looking for something that is just relatively machinable, cheap and, easy to replace if I need. And it just needs to be strong enough so that when I'm actually milling traces in the Pyralux material, when it passes over one of those gaps, where where that screw hole is, if there's any gap in the support under the material, then it just won't mill. It'll kind of press the material down and I'll get a gap in my trace. Or rather, a gap in my gap. So there'll be a little bridge of copper right where that hole is. So I think I might just try, I have this, here it is, materials. Is this still broken? I think I must have messed up my hotkey settings. Anyway. So this is the actual material. It's pretty thin. I got it in a kind of a big sheet, and I just, before this stream, cut a few of these squares that are just the right size to fit in my milling machine. So about 5.5 by 4.5 inches. We'll measure this with calipers once we get into the milling closet, but it's... Oh, actually, I have calipers here, don't I? I was using them for CAD just a second ago. Yes, here they are. This is going to be very, very thin. So it looks like about 0.09 millimeters. So yeah, about 1/10 of a millimeter thick. And I wonder if we can see under the microscope like what proportion of that is the Kapton and what proportion of it is the copper, because I'm kind of curious about that. I think I don't know if I got full specs for this stuff when I ordered it. If I did, I'd probably have to dig through my email and look for an eBay receipt. It'd be hard to see that while I'm holding it all wobbly like. Let me try bracing this on a clamp of some sort. Also, we really don't need that to be microscope only, do we? Alright. Yeah, I think somehow I blew away my hotkey config file. Like, I was testing something earlier to make sure that the keys I wanted to use in this project would work properly, and maybe I accidentally saved some of those changes when I didn't mean to. Maybe some more light. Yeah, okay, well this is not going to be a viable approach for even seeing the layers in this stuff. It's so thin. I mean, it looks like it might be roughly like 2/3 copper and 1/3 Kapton in this case. Anyway, this stuff is very thin. One thing that I had to do previously, maybe while we have the microscope up, we can take a look at some of the previous failures and successes here. And got the success, here's the failure. Alright, I should clean this desk. There's a little too much going on right now. So, this is the same Pyralux, but with, I think this just has double-sided tape on the back, and so you can see it's actually quite translucent where the copper's been milled away. And this was mostly working out. Oh, that's still very, very zoomed. That's the back side. So you can see this was getting a little bit torn up. I think either the tool was a little bit dull or the material wasn't held down super well, or possibly both. And then it ended up kind of breaking through and tearing it up. But yeah, where it cuts through the copper, you can see that's like a very thin layer of Kapton tape. So I think what would actually be ideal for this is to use Kapton that has I think what would be ideal for this is to use a Pyralux that has a thicker Kapton layer. And since I didn't have that handy, and I think that probably would have been a lot more expensive too. I've just been, adding my own additional layer of Kapton tape on the back, which seems to do the trick just fine. So, my favorite process so far involves putting a layer of Kapton on the back just for additional structural support, and then after doing the milling, putting another layer of Kapton on the front to act as basically a solder mask and to be more mechanical support and kind of anti-corrosion. Let's make this full screen again. Okay, so this is a bit of a crazy thing. So I'm probably going to have a lot more to say about this on future videos. You can see in there, so this is like an industrial controller, and it's based on this same TI microcontroller with Ethernet that I've been doing some separate work on trying to extract firmware out of with glitching. So this is the one I actually want to extract the firmware from. And so eventually I will also want to be able to load my own firmware on here and do in-circuit debugging. Plus, even just right now, before doing the kind of additional effort to extract the firmware the hard way, I had to at least make sure that the debug port wasn't just enabled on this so I could extract it the easy way. So I needed to make, well, I could have just soldered wires on for JTAG, but I wanted to make a slightly more durable JTAG adapter. So this goes from a standard 2x10 JTAG header that I can just plug into whatever dongle I want to use. And then on this side, it's soldered kind of surface mount hotbar style to what normally would be like a connector for like a wire harness on the board here. Let's see if we can get a little bit closer view. This is also a terrible soldering job, I know, but my goal here was to separate the chip's VCC from the VCC plane. So I did that by lifting all the power pins and attaching them to a new copper plane. And it worked. Yeah, so there's some detail on the flex assembly. So that's basically what I want to do for this next project, except with a teensy here instead of this board's debug port. So having a flex kind of dangling off from a rigid circuit board with a microcontroller on it. And it'll be, yeah, the way I'm planning on doing this actually has the flex kind of underneath the teensy. So then it'll be flex on bottom with buttons on top and teensy on top with a joint similar to this one. Can we get any interesting details on the flex itself with this view? It's a little harder to see what's going on since putting the Kapton over everything. But this is I think this was the backside when I milled it. So this was the Kapton layer that I put down over everything. And then I think the other side has some more detail. Huh. Can already see a little bit of oxidation in that copper. I guess there was some moisture trapped between the layers. And some boundaries between my layers of Kapton tape. And then these were, this is one way of doing jumpers. You know, I could have done a second layer of the same Pyralux material, or I could have done little tiny wires. I was actually originally planning on just using little wires, but then I kind of on a whim decided to use copper tape. So there's a layer of Kapton between the copper tape and the Pyralux, and then another layer of Kapton on top of everything. And then here you can see test points where I cut away the multiple layers of Kapton to reveal the actual pads. And one test point I decided not to use. So I'm going to be doing something kind of similar to this. Leave the microscope with a view of the failure while I'm putting the good one away. Oh yeah, you can see some really grody machining marks on that one. That cat is super chill. After I was pretty far into making that JTAG adapter, I kind of found out what the model number was of that that connector the board was actually designed for. So another approach would have just been to order that connector and get like the same wiring harness that presumably the original developers were using for their JTAG. But one thing I liked about this approach, and one reason I wanted to try it out, is that you can use it to make an adapter for literally any footprint you want. So, you can just take any layout that you find on a circuit board, and if you can measure it, and if you have machines that can handle the tolerances you need, then you can make an adapter out of flexible circuit board material. I mean, for most usable adapters with lots of signals, you'd probably need more layers, which would be difficult. But one thing I kind of like about this flex technique actually is that it's kind of a good reason to do single layer design, which I find kind of fascinating. Let's see. Okay, so we looked at this material. The other material I wanted to look at was this plastic that I was thinking of using as a shim. So this is, what's this called? KiCad+. Let's get the other camera. This remote does that same thing I was complaining about before where the wireless goes to sleep. I'm definitely going to like having a wired camera switcher. So I might end up using acrylic as the kind of temporary backing material for milling the Pyralux. Because I know the acrylic is going to be nice and stable, but I think this is still going to be thick enough because we just need to take off a very tiny amount from the top to make it totally flat, and then the remaining material just has to be strong enough to keep the Pyralux from bending while we're machining it. Which, given that we're taking pretty light passes, it shouldn't have to be that strong. So I think something like this. Other options might be, stuff like cardboard, but, I want to avoid materials that have kind of a non-uniform interior structure, so stuff like a cast plastic is going to be really nice. So I think I'm going to try this first and just, use double-sided tape to stick it down to the machine's aluminum spoil board, and that'll cover up, any gouges I have in the aluminum, and it'll cover up the bolt holes. And then from there, I will take a very light facing pass on this whole surface, just to make sure that it's absolutely flat in the mill's coordinate system. And then I want to attach the Pyralux to that in a way that is sturdy enough for milling, relatively easy to get off later, and I want the attachment to be very, very uniform in thickness and very, very thin. So instead of using tape for that attachment, I've been using just a thin layer of like glue stick, like you'd use for paper or 3D printer. And I've just been using a thin application of that and then using a squeegee to really get the Pyralux flat onto the surface. So I know that works with the aluminum. I think it might work with this too. Oh, and I have this material mostly because it's really good for vacuum forming. I did check, and it does seem like it's machinable, and people do machine KiCad+. But yeah, I got it for vacuum forming some parts for an art project a while ago, but then I didn't end up getting to the point where I was going to use these, so now they're still hanging around in my excess materials. But it's a pretty good material for vacuum forming, and one reason I got these is that it was an easy and cheap way to make a thing that had a shape that was whatever I wanted, that was also very opaque, because this has a lot of pigment in it. But in this case, that doesn't matter. All right, let's go back to the CAD land. Sorry about the slurping, but I need to caffeinate. All right, so I think we're happy with this trace squiggling. This looks much nicer. I might still fuss with it very slightly, but big improvement, I think. Like, mostly what I'm looking for is clearing out a bunch of space in between here so I can adjust the outline. So I think I'm going to call that good. Let's exit routing mode and save this. Now I just want to get this back into Rhino. So let's see if I can use... I was kind of expecting this to have a DXF export since it has a DXF import. But maybe what I want is to do a plot. Yeah. So I think we can do plot in DXF. I think I really just want front copper and edge cuts. Those are the only layers I care about right now. And working with this in Rhino should be pretty easy. Getting it back in here, I don't know if I'm going to have an easy way of aligning it perfectly, but I should be able to align it well enough for the tolerances in this project. Since I don't know of good ways of, moving parts relative to reference points on drawings in KiCad. So, where is this going to throw my files? I was hoping you would make that directory for me. Okay, I think I just exported some DXF files. Let's see if Rhino knows what to do with these. So I'm going to use insert. And it's in here, plots. And I want both of these. Can I not import them both? I guess I'll get one at a time. Let's get the copper first. Import it as... I think I just want this to be a group of objects. That's my Rhino rendition of the copper layer. Are these like filled shapes, or are these not filled? I guess these are just outlines. That's fine. I mostly just want the coordinates for these. I don't really care what kind of shape it makes them. But I want to get a good mechanical idea of what the copper is actually like. So let's import the other file. Same deal. All right. And so I used the origin and kind of default coordinates for that, so they should be lined up relative to each other. And now I'm just going to use this version of the shape as a reference point to get this lined up relative to the Rhino coordinate system I've been using. So all these curves, there aren't a lot of nice edges to use as reference points, but I'm thinking maybe I'll actually just rotate this 90 degrees since I think I don't have to worry about a weird angle here. And then oh, let's turn the gumball on. I missed the gumball. Good old gumball. So I think I'm just going to use the center of this edge as our important reference point, because that's, the place where the teensy attaches is pretty important. And this is not going to give me a midpoint snap, is it? Oh, I had a bunch of stuff turned off. Why is all my object snap off? Okay, great, that's better. Just enabling a bunch of Rhino features I can't live without, don't mind me. That looks better. Great, so now we should have the original Rhino files, or objects, and then these kind of blocky traces that we've just imported from KiCad. I'm going to save that. So now what I want to do is to use this curve and the traces as a guide to make a more minimal exterior shape for this. So I think I'm going to start by just drawing some kind of rough polygons to exclude from this. Maybe there's a more algorithmic way to do this. Because really what I want is a certain amount of buffer space around all my traces. So maybe I can just use some curve offsetting to get there. Oh geez, this is a layer explosion. Ah, the DXF files have layers named after colors. Yes, all of those objects ended up on a layer named after the color black. Sure. Guess I can rename that. Call that layer my KiCad imports. And let's make that stand out a little. Like, ooh, orange on gray is not so visible. That's a little better. Great. Back to the flex circuit, and then we can turn that on and off. So, let's see if we can offset this in a useful way. This might be something I have to use a slightly different tool for, like Grasshopper. So this will offset surfaces, but that's not what I want here. Yeah, I mean, what I really want is well, what kind of object is this? I think these are actually just lines right now, so there isn't even like really a notion of what's inside and what's outside. Yeah, object type over here. Oh, that's under the other thing. I pop that out. Object type 2589 open curves, which are great for locations, but like if I was drawing something, this would make a fine reference, but this will need a little cleanup before I can use them to do something interesting here. And I think this might actually be an opportunity, like, the logic I'm going through in my head is, oh, there's probably an easy way of doing this in Rhino, but I would probably just use Grasshopper for this. So maybe I'll just use Grasshopper. This is a plugin for Rhino that is, it's part of the reason Rhino is so awesome. It gives you kind of a algorithmic kind of data flow like visual language for working with geometry. And it works in parallel with Rhino. So while this gives you a view over here into the world, you can kind of be working on this like program over here that manipulates the data. It's a little bit like MaxMSP or some other data flow languages you might have used. So I think what I actually want here, these are curves, and I can bind this to an object in the Rhino world over here. So I think I've just set this to the curves I've highlighted over here. And those are now stored inside that object. If I turn this stuff off, we should be able to see that more clearly. Yeah, great. So I've still got all that stuff there, it's just hidden. And now I have a Rhino or a Grasshopper node here that has all of our traces from KiCad. And these are all just like loose wires, they aren't even like real polygons. But that's not really a problem, since I think what I want here is just to kind of, if you imagine just drawing a really thick line along each of these lines and then unioning all that together, that's kind of the shape I want. So I think we can just make that happen. So we can see what kind of objects we're dealing with. We have a bunch of tiny lines here. Now I think there might even be an easy way of doing this directly, like something that takes a line and then offsets it. So this is an operator that works on curves, and let's just see if this does what we want. I can set the input or set the curves to be smooth, round, I think we want. And by default this will work in the XY plane, which is fine. I connect that input data, and now for each of these lines, it's given me another line that is offset to one side by whatever this amount is, 1 millimeter. So I think what I actually want is to do something like offsetting that on both sides and joining them, but I think there might be a way to do this with less geometry cleanup, actually. There also might be a way to get what we want directly in the form of a mesh. There are so many little doodads in this language that you can attach together. I think the most straightforward way to do this is an extrusion, maybe. I don't know. The offset seemed like what I want, because I do want that round cap on the edges. So maybe there was actually just something I was doing wrong with that, where I want the lines... Oh, you know what? I want the lines to all be treated pretty much individually. So maybe that's something where, like I think if I flatten this list, does that help? I mean, there are other ways of getting this same result, like, I mean, it's just baffling why this isn't doing what I expected it to do. So it would be nice to figure that out. Let's try setting this to a larger number just to make sure I know how this is supposed to work. That's interesting. Let's try this with one line at a time so we can get a better idea of what's going on. The data flow here is kind of interesting. Like at first, there's definitely a learning curve relative to other ways of accomplishing this, but part of what makes this powerful is that the fundamental data type here is kind of a flexible tree of objects. So you can represent operations on kind of recursive collections of geometry relatively easily. But then other things like choosing an item from a list, I have to remember how to do that. I think it's this one. No, that finds an item. Oh, list item? Oh, that's what I want, yeah. Okay, so I'm picking item index 0. And this should be getting one line as its output. So if I turn off preview for these other items and have preview on for this, I should see one line somewhere. Well, let's try a different line. That's strange. Let's actually display the values we're getting. I don't know how to get more information from here than line-like curve here. Well, I mean, I guess I can take apart the line. There's a doodad somewhere around here that gives you the endpoints for a line. This goes faster when I remember what things are called, and I can look it up with the search. Oh, endpoints. That's what I want. Oh, points are easier to find. Let's sum these. So I guess this is just a very small line. Is that our problem? Very small lines? So what happens when we try to offset this? Let's see if we can find a better line. So this will be a number slider that just lets us pick different lines to examine one by one as we try to get this working, and then we can just do all of them. That doesn't seem like it's working. Oh, this is being overridden by an expression here. Okay, now we're getting different values at least. And are they all over there. Oh, cool. Great. That looks much better. So now I can drag the slider, and for each position in there, it's just giving me one of the lines that we exported from KiCad. And now we can take a look at what our data flow is doing to that line and get it to make something that we want. Let's find a nice long line like this one. So, that red thing is the XY plane, which I think it's showing us because one of, I guess it's visible here for some reason. One of the inputs here is the XY plane. And then the little crosses here are points coming onto this decomposition here where we're looking at the endpoints. And then this offset is generating a line over here. So what I actually want is not just a line that's moved over. I want it to offset that on both sides. So I think that maybe that's an extrusion and not an offset, or maybe I have to do that manually with 2 offsets. Yeah, maybe that's some kind of extrusion. No, maybe. All right, well, maybe I'll do this at a slightly lower level. I thought there was I mean, there probably is an element in here that does exactly what I'm doing here, but I think I might just build it up from slightly more basic parts to get a feel. So we want another parameter that's going to be the width of all of these pieces. So let's just get another number slider, and that'll be the offset amount. And this will be basically the clearance that we want between the edge of the Flex PCB and the actual traces. So, you know, let's give ourselves a max of like 15 millimeters, because that's pretty big at this scale. And we probably want something that's more like around there. So I think what we want is just another offset on the other side. Let's just make a negative version of that. And I also want like a round cap on both ends. That's not going to matter for the vast majority of these lines, but you know, a lot of them it will, and especially the short ones, the cap might end up being more important than the body of this shape. So let's create a circle. There are different ways of defining a circle. I think I want it center, normal, and radius. I think that's what that stands for. And so I do actually want these endpoints, but we can stop displaying them separately. So the radius is going to be that same value. N is the normal, which defaults to Z+, which is exactly what we want here. And then for center, so I'm going to use this kind of tree functionality, and instead of having 2 instances of this, I'm going to have 2 data items going into it. So I'm going to hold down, I guess, Shift for addition, and both endpoints are going to make circles now. So 2 circles, 2 lines. Now I just want to join this into something, because ideally I want to make like nice, well-formed polygons that we can join together into nice Boolean operations. So I think the ways to do this are to first join together these 2 curves into a closed system of some sort, and then Boolean in the circles. So this is a line made from 2 endpoints. I think what I want to do is decompose each of these offset lines into their endpoints, and then kind of wire them up in the correct order. So no, I guess that's what I want. So I think now we have, between these four elements, we have lines that we can join together. Yeah, so this, I don't think this is going to care what directions the curves are in. It'll notice that these are the same point, and it'll join them into a continuous polygon. So in this case, I just want to add a bunch of these together. So now, if we hover over the output, it'll tell us what we have. One curve, which is a good sign. And I'd like to know if that curve is closed or not, because that will tell us if what we did was successful. I think polyline curve means it's closed. I think it says something separate if it's open. So, okay. So we have our box, we have our end caps. I think now we just want to Boolean those. Region union, yeah. So this is a union of 2D objects. 3D unions are harder and more likely to fail, so it's good to do as much of this in 2 dimensions as we can get away with. So P here is again a plane to work on. We're still going to use the default XY plane. Then up here, union that, and the circles. And I want this to flatten all the values into a single list and then union them together. I think that's what I want, but the preview is getting a little cluttered. Let me turn off a bunch of this. I usually try to turn stuff off as I'm going, because I don't know if there's an easy way of turning off the previews on all the objects at once. There we go. That is the final shape that this little object tree produces from our input curve. So we should be able to vary these parameters and watch how that changes it. And the next test is to vary the input line and just see if it has any problems for other line shapes. That looks nicer. So now I think instead of just choosing one line, let's try to apply this to all the lines, which I think just involves deleting this box and running this directly into the inputs. Should maybe pause calculation during this part, because it's going to try to do a bunch of stuff. Grasshopper not responding. Yeah. It's often gets into this state because it tries to do the solving on the UI thread. Probably should have saved this before making that connection. Okay, let me save this right now. So that's interesting. So we haven't connected the end caps yet, so this is what we would get, just for example, without the end caps. A lot of kind of weird, fractious bits of stuff that we don't actually want. And then those inner bits, but I think we'll just clean up some of that manually, or possibly have a part of this chain that kind of discards the the kind of inner islands like that. Anyway, this is saved. Let me turn off calculation. Yeah, disable solver while I connect this. Okay, then re-enable solver. And it's gonna sit there and compute, and then we'll see if it looks good. I might have made that diameter way too small, actually. Adjust that after this calculates. Oh, Tuco's enjoying that chair over there. Crunch, crunch, crunch. Definitely helps to have a way of caching results when doing bigger things with Grasshopper. Although often if it's this slow, there's something I can do to make it faster. Like I might just be doing something in a silly way. I might also disable this union, because I don't really need to do that final union just to see what's going on, and I'm sure that's what's taking so much time. Yeah, maybe let's force quit this and come back without that union, because I don't really want to wait for that. Why did I save it in that directory? Oh, I probably should have turned off enable solver. Yeah, that gave me the opportunity to disable the solver while I was opening it, and I should have taken that opportunity. Let's try this again. Okay. Disable solver, ignore recovery file. Great. That's what I wanted. So let's not be doing the single item thing. Let's be processing all the curves, but I'm going to turn on preview for the inputs to the union and disable the union itself. So that should actually complete in a reasonable amount of time, and we can see what's going on. So save that, and then turn the solver back on. There's also probably just way more wires in this than I actually need. So yeah, I think we want this to be a little wider. That still takes so much recalculation time. And I think a lot of it is just like these really tiny wires that form the edges of the curves here. Whoa. Okay, solver off for a sec. Let's set this to How about 1.8 millimeters? That seems nicer. Maybe instead of trying to do the final union programmatically, I'll just take over from here with Rhino, as I think this is what I really wanted to do with Grasshopper, was get to this point. So I think that's enough margin. It should still fit within the material I had available here. So yeah, this green border is what I was originally planning on using for the board outline, but now this red boundary is probably going to be closer to what I actually use. You know, I'll simplify it a little bit, but something more like that. Except for over here, I still want this tab to be full width. Alright, so the way we get this stuff out of Grasshopper is I'm going to take this and this, oops, both of these things and bake them into geometry. And stick that on the default layer in a new group. Now I think we can be done with Rhino, or with Grasshopper for a bit. All right. I don't know why we still have a copy of this on the default layer. Let's make a new layer for this part. Let's just call this zigzag. So I think I want everything on the default layer except for that outline and that square. Oh, Grasshopper is still running, and that is still output from Grasshopper. That's right, when you close the Grasshopper window, it doesn't actually exit Grasshopper. That's better. I guess I didn't export the lines successfully. I guess I got these from somewhere. Let's try that again. All right, let's undo that bake. I feel like half of CAD is like layered janitorial work. Kind of like how most of programming is like naming things. I tried to bake both of those nodes with them both highlighted, but I think I might have only succeeded with the circle, so let's just try them separately this time. So these are just the circles, and these are just the lines. Bake those, default layer, and bake these in the default layer. Okay, that seems better. So now I really want to just Boolean all of this stuff together and hope that that does not crash Rhino. I think curve Boolean can handle it. Good morning, curve Boolean. Man, we're not even doing the Boolean yet, it's just like loading the tool. Maybe this is a good time to make another cup of coffee. I mean, there are probably changes on the Grasshopper side that would have made this easier, like simplifying some of these traces with lots of tiny little wire segments. But I mean, after I reduce this, then it should be simple again. Like, I shouldn't really have to worry about all this complexity, assuming I can get past this Boolean. Oh, you know, it's probably... So this command is trying to load, I think, a preview that it's going to show as it asks me what parameters to use. Yeah. I wonder if there are any opportunities to simplify this before going through this step. Poor little single chord solver. Oh, it is allocating some memory furiously, though. Alright, well, maybe I will actually make some coffee, do the stereotypical thing to do while waiting on the computer, because I don't want to necessarily cancel this and backtrack, since I think this is the right way to do this, but if this fails, there are other options. This is just probably still the easiest way to get the result I'm looking for. Except, I mean, I guess I could just like trace it by hand with the snap tools instead of doing the Boolean on the computer. Alright, well, maybe I will make coffee and say hi to Tuco, and if this isn't done by the time I make coffee and say hi to Tuco, then I will use an alternative approach. Hey, cat. The camera's way over here. What's up, cat? Quite see Tuco eating. Progress. No, I figured I was already over caffeinated and made some mint tea instead. I think I'm just gonna do this some other way. All right, let's try this some other way. Okay. These are all closed curves. I'm not sure why they aren't rendering when I switch this to like a solid view. Hey, cat. Oh, that's not Tuco Cam. Hey, cat. He likes one of these 3D printed buttons. He's purring. Hey, buddy. Tuco, you're such a distraction. I think he likes the way these feel. They're printed in semi-flex. Oh, cat. Well, maybe I can union these together in smaller groups. Like... Let's see if that makes any more progress. Delete input. Yeah, okay. That's a good step in the right direction. Let's do this in smaller pieces. I guess this algorithm probably just has some terrible complexity explosion. Hey, Tuco. Oh, Tuco, what are you doing to my binding posts? Cat, if you're gonna be cute, I should at least get it on camera. He's just being a cat. Doing all them cat things. That's not what I wanted. Hey, Tuco. There are a lot of things I don't mind when he does, but he does mess up wires and stacks of paper in ways that I find annoying sometimes. Hey, Tuco. Resistors aren't for you. This is definitely one of those things where, all right, it would be nice to do this programmatically, but it would also require Grasshopper or whatever other tool to have a better system for dealing with like progress on long operations. Oh, Tuco. He is biting into the binding posts on my breadboard here. What? Hey, Tuke, let's get you off the desk. Maybe I can bring the camera back over here. Hey, tiger face. This is also one of those cases where it'd be really nice if the UI even just had an indication that it was busy. Hey, Tuco. It's like he's not used to me working over here when I'm not actually doing electronics. Oh, Tuco, resistors are not for you. This will give me a good starting shape. There's definitely some stuff that I want to simplify about this. And I'll probably do just a fillet to get rid of any sharp corners. I guess if the space mouse doesn't work, it's pretty easy to tell it's hung. I hear you, Tuco. You want to play? Ah, still so stiff from falling on my spine the other day. Yeah, plenty of opportunities to get hurt in this shop, but so far the most dangerous objects have been tiny pieces of metal on the floor and wearing socks and then slipping. So I've got the curve boolean command just deleting all the pieces that it makes use of as it does so. Once I get this down to just a couple of things left, then I think I can just do one overall boolean and clean up anything that's left. Hey, Tuco. Not delete. Hey, Tuco, I need slightly fewer distractions. Hey, Tuco. I know you're into that paper. Do you want the graph paper to be on your chair? I can make that happen. Do you want to be sitting on the graph paper? Maybe not. Maybe he doesn't care about the graph paper unless I care about it. I know, isn't that interesting, Tuco? Getting close. Such booleans. Oh, now Tuco's eating more. He's got important things to do, that kitty. Okay. Can I start making bigger unions now? Is this the last one? Will it crash? I think it's getting there. I think it just failed to allocate enough memory for the order of n cubed operation it was trying to do on all these tiny circles before. Or whatever the algorithmic complexity is. Okay, so now what do we got? So we have mechanical references. So here are all of our tack switches. Here's the maximum outline we decided on. And then now here's the minimum outline dictated by the traces we have. So, hey buddy. I want to simplify this, but in a way that mostly just makes it larger. I might just try a simplify command first. And fillet corners. Yeah, that kind of failed. The other thing I might do is just union in some other shapes with some of the problematic edges here. Tuco, you're back so soon. Don't claw the screen, little guy. Oh, Tuco is so rambunctious today. I guess I'm not used to streaming at this time of day with the little tiger. I hear you, tiger. And these didn't quite make it. Let's fix these two. That looks better. And then maybe we can fillet the corners a little. That helped for some of the corners. Cute. So there's our zigzaggy flex circuit outline, which seems alright. What else do we have? Yeah, so that'll be synced pretty well with the shape of our teensy. A lot of these little protrusions are for the resistor that goes next to the button. So I think now I just want to get this back into KiCad. And the alignment of this isn't super critical. I mean, the main thing that this has to do is clear all of the traces. So I think I can just export this shape and then import that into KiCad and then just kind of manually align it relative to the stuff going on over here. Although it is tempting to make this tab still the original shape. Maybe I'll find a way to do that. What layer is this on? This is default layer. Let's make a copy of this. And then let's split this in a couple of places. Okay, now we've got just this little piece that we want. And I think what we actually want is something kind of like that. And then like that-ish. This needs to be on that layer. Okay, now let's throw the curve Boolean machine at this again. And I want to get rid of that region and keep those. More fillety than that. Let's make this 2mm fillet. It has trouble filleting things that are already curves like this, kind of understandably. But let's fix this up a little. That's better. There's some other places I kind of want to clean this up. Looks like a couple of these, you can see like some bumps here that aren't especially necessary or helpful. Ooh, that's not great. That's the edge I want. Oh, except I want that to be sharp. I'm cleaning up these kind of messed up corners so that I can fillet them cleanly. That's nicer. Plenty of room for this material to kind of squish around without the, because you can imagine, you want it to move or to curve in a couple of different axes. It's also going to involve, like you want this material here, even if it's bent in this axis, to still have the ability to stretch in this axis. So having a gap here is useful, whereas just cutting it with scissors, it would tend to bind up at that point as they kind of push against each other like tectonic plates. That's still a little lumpy, but I don't care. I'm going to get this back into KiCad now. Let's export this. So oh, that's the air compressor. I forgot I still had that on. All right. We're going to be using that in just a minute when we start milling this. Okay, so there is this handy import DXF, which we should be able to use. Curvy outline, and I don't see an easy way of changing the layer on one of these drawings later, so I think I have to start out putting this on the right spot. So that would be edge cuts. And I'm going to start out putting this somewhere just out of the way, because I have to get rid of the old layer somehow. I mean, the thing I'm sighing about right now is what I really want to do is move this over top of this using that as a guide, but then I don't think I'll have an easy way of selecting all of the old edge boundaries to delete them. Oh, hide. a lot of commands for hiding and showing copper layers, but I didn't see commands for hiding just all the layers. So I just want edge cuts. Just the cuts. It's still displaying pads, but that's fine. I don't think those will highlight, will they? I might have to delete that piecewise, which could be annoying. Well, I think maybe the right thing to do then is to make a reference on a different layer that I can then align that with. So, oh, okay, I already have that on a different layer. I have this user drawings layer, so let's keep that handy. And delete what is currently on edge cuts without deleting any pads that I need. Can I hide components? If I could hide components, or at least not select them, that would make this much easier. I think that's a pretty big curve. Maybe I can just deselect the components. No? Oh, double clicking on the line does something different. Great. Double clicking seems to instantly make the line selectable and then also bring up that dialog box, but then there's something I can do subsequently to make it selectable again. Huh. Anyway, cleaned up that little mess, and now I can use that as a guide to put this in the right place, I think. Let's try to grab this in a slightly easier to see location. Oh. Okay. I think what I actually want to do is grab it near this corner, and then I can use that to line it up as well as I can while zoomed in. That should be within 1 mil, which is fine. Yay, that looks right. Where's the cat? I guess cat's upstairs. Anyway, we have some outlines. So I think we are ready now to export these layers yet again from KiCad, but this time instead of going to Rhino, we are going to the other mill. Yeah, so I think, so step one, I want to do a test export here just to import stuff into the other mill software on this computer, just to make sure it looks right. And then I can kind of switch the setup very slightly so that we can go into the machine closet and actually start the operations in there. And I think the first thing there is actually not even to use this this design necessarily. The first thing is actually just to face that Kydex plastic sheet flat. So, yeah, that might be an opportunity to catch up with the cat while that facing operation is running, or we could get started with the enclosure design around this piece. So let's just make some plots. This time Gerber format, because that's what the fab software knows how to read. We want front copper and edge cuts, just like before. Those are the only layers that really matter with this project. Plot. Let's see if we have the other mill software in here. Maybe not. I'll download it real quick. The other mill software used to have this feature where you could you would like save your machining setup as a file, and that was actually kind of handy because then I could set it up on this machine and yes, elegant software, let me download it. But they had a pretty major rewrite of their software to make it portable, because the original version was macOS only. And it's kind of taken them a while to get back to feature parity. I think that's still one of the things that they don't quite have is loading and saving setups. Somebody, I just saw in chat a question from Jarrett about how many machines/VMs I have here. And those are very different questions. I've probably got a lot more VMs than machines. I mean, not that like run continuously, I guess, but, and it also depends on what you mean by a machine, like a full-size computer versus like a Raspberry Pi or something else that runs on ARM, or like an Android phone. But let's see, I mean, so out here running the stream, there are basically 4 computers at this, like on this side of the shop that run the streaming / recording / video editing and everything else that I'm doing right now. Like 3 Macs and a Windows tower, and so I'm on the Windows tower right now. But then there's also another like guest Windows machine in the shop, and then in the machine closet there's actually another like super underpowered Windows machine connected directly to the mill. And so for the next step, I'm actually going to be we'll be VNC'd into that machine for video recording purposes. Let's see. Anyway, let's open the file. Gerbers. So we've got a copper layer and an edge cuts layer and no holes. First step is rotate this so it fits on the machine, which might have been easier to do in some other piece of software, but it'd also be cool if there was a way to like drag with a modifier down to cause these to scroll or something. So this should just barely fit. The material we're using is not single-sided FR1. Let's tell it. So I think this is the full size. No, that's not the full size. I forget what the size is in metric. Let's get a calculator. The size I've been using is 4.5 by 5.5 inches. So 114. 139. Yeah. So that's like the size of the aluminum spoil board, which is what we're limited to. That was just the dimensions in there before were, I think, the size of the FR1 blanks I usually use. So then, that's the material. Yeah. The other thing, I do probably want to leave an area clear on here for the tool to touch down. So I actually probably want to make this a little less in the X direction if I can get away with it, which I think I can. So like, not that much littler, but, oops. I don't know, maybe something more like one, yeah. Just leave enough area over here that we can touch down there to get a reference for the tool. So as you can see, this will be a little bit of a tight fit on the mill, but should totally work. And then we should have spacings that allow the whole thing to be done with just the 1/64th inch. So yeah, this is roughly what we're looking at. Let's make this a little bigger. There's our cut all the way through to separate the piece. This is also much thicker than the actual material. I mean, this should be more like that. So I guess that's all we need to do on the kind of software prep side. Got this footage. So yeah, I guess all that's left now is to just go into the machine closet and start facing a piece of that kydex that I want to use as a backing plane for this. So that would be, there's an option. I thought it was in BitBreaker. Anyway, we'll probably see this in the tool with the machine actually connected, but because I think some of the options don't show up when the machine isn't plugged in. But there's some way to, from inside this software, generate a toolpath for facing, so I'm just going to do that. It's what you would use to kind of clear up this aluminum plate if it's damaged, or if you're installing a new one for the first time, or if you're recalibrating your machine. But in this case, I'll be doing pretty much the same operation, just with a Z offset of a little less than the thickness of the material I'm adding. All right. Let's get the other machine pointed back at the VNC of the machine closet. That's what we want. This is the usual Mac that we have been doing Arduino stuff on. Relax and enjoy Windows 10. And what else we got? So that bottom screen is the computer in there. And I think, so I've got my wireless headset for audio. I also have my wireless video solution, which is a little Android phone with screen mirroring. this is kind of nice because, well, there's a lot of things about it that aren't so great, but I can at least use it pretty easily to record from a lot of different angles, and I can get footage locally and stream at the same time in reasonable quality, which I can't really do on a GoPro. Should have some video coming in. Yeah, great. Hi. So, this is the mobile camera. There's Tuco down there being confused about what's going on. So, I think the files we all need are over on that machine already. I'm just going to bring the chat computer with me so that I can see when things go horribly wrong. And we need some materials. So, bring the KiCad+ and Pyralux in there with us. And streaming. So much streaming. Alright. Let's see how to go about this. Gotta make sure my connection hasn't dropped. Alright, I think the way we did this before was I mostly just sat this up here on the shelf as a getting stuff ready selfie cam kind of thing, but maybe I can actually have this get a better view of, like, I think I want a view of the stuff down there. Could it be on the mill? This is a silly little tripod with flexible legs. So, something kind of like that? I don't know. I'll probably move that around. Try to keep that where I can actually see it so that I know when things go horribly wrong. So, here's our sheets of Pyralux. There's a little bit of prep we can do to these. I want to put some Kapton tape on the back. That's interesting. I just saw the screen over here flicker, like VNC disconnected. Huh, let me check the streaming. Oh no, it looks like it's back. Oh yeah, I think, man, it's hard to tell out here on the delay whether this is viewing the correct machine or not, but I think it is. Alright, I was a little worried that the VNC viewer had closed and it was viewing the other computer. Let's get other plans started. And so this is the plastic. Let's maybe go ahead and start recording. And so this is the KiCad+ plastic that I wanted to use as a backing sheet. So the first thing I want to do is just attach this to the spoil board in my mill. It has two sides that are a little different. There's kind of a shiny side and a rough side. So I'm going to start with the shiny side up, since it seems like the rough side will do a better job of adhering to the bed, and the shiny side will do a better job of being smooth. So I want to attach that. I also want to take this bracket out of the mill and get it set up to do the facing operation. And I want to be sure to cut a corner out of this so that well, I guess I don't have to cut it, but I want to make sure to leave enough space here to do the touch zeroing. So if I kind of scoot it a little bit over and not, center it exactly on the build surface, or cut a little strip off of it, then I'll leave enough room for that, or even a little notch. Hello, zeroing. All right, got some zeros. Let's tell it to remove the bracket. Yeah. It usually stores the locations for stuff like this. Oh. It doesn't actually tell me to do anything, it just clears that data, so then I can remove it myself. But yeah, it stores data like the location of the bracket. I think it actually stores that in like an EEPROM in the mill. So even between sessions, like you don't have to re-zero this thing, or you don't have to relocate where the parts are. It'll still like re-zero the actual tool, but it saves locations of all this other important stuff relative to that zero. I guess if I'm recording video on the camera, it probably won't decide to power down, which is another nice thing. It's hitting that problem where the Android phone app was like, touch the screen to keep going. And I'm like, but I always want to keep going. What are you doing? So yeah, I cut that. It looks like exactly the right size for that. So I'm just going to cut a notch out of one corner so I have room to zero the tool. Also, it's nice that this stuff is thin enough that I can cut it with scissors. I worry slightly about having like a slightly curved edge when I cut it with something like that, but I think the thickness of the tape combined with the facing operation we're about to do is going to make that less of an issue. Flatness is really the name of the game here. We want things to be very flat. So I think I'm just going to use a bunch of tape for this. Do I want to use this tape? I think I want to use the strongest and most consistent tape that I would use for this, which is this Nitto tape, N-I-T-T-O. I sometimes use this just Scotch tape, which isn't as strong. I think it's a little thinner. I don't necessarily trust it to be as consistently thick as this stuff. Anyway, I'm a little bit worried about how, like, if I don't bring the tape all the way to the edges, then I'm basically setting up like a shelf, and then there's like a spacer under it, and then there's another surface, and so there's kind of a lever edge. So like over here, that's not going to be as stable, but I mean, that's definitely the kind of thing that I want to avoid on the next layer up, which is why I'm using glue stick. But for this, tape seemed like a better idea than glue. This tape might also just be total overkill for this. It might just be this is fine with a much simpler adhesive strategy. This is probably going to be really annoying to get off when I'm done with this, but I also think this is something that I can probably leave on if I'm milling multiple things with Pyralux. Like, that this is, you can think of this as a disposable attachment that you can use repeatedly, but if you mess it up, it's not that big of a deal. Come on. I'm still not very good at this trick yet. There's like I think a particular angle you have to put the knife blade in at for that to actually work. Whoops. Let's not get my fingers stuck to everything. I hope this new version of the other mill software has facing. I'm realizing I don't think I faced my bed since this last like huge software update, but I don't know, maybe I have. I'm sure it has that feature. Well, I mean, I guess worst case, I just have to make some G-code in another tool, or possibly download something from the other or other mill website. They might just have G-code for stuff like that. It's like one of those things that is like trivial, but it's like nice to not have to worry about generating it. Okay, got a bunch of tape on this thing. I'm also wondering if maybe it would be easier next time to use a spray adhesive like Super 77. Just like spray this outside, well, not like outside, but like not in this closet probably, and then I'd have a nice uniform-ish coating of adhesive on here. I'm a little worried about this square. Oh, there's a little overlap there, which I didn't want. Let's trim away that overlap. Okay, that should be alright. Still getting video here? Oh, I saw this on the stream and I thought it was that, which made me think it was hugely lagged, like, oh, I haven't put it on any of the tape yet. But, alright, so here, this isn't going to be super critical, but I'm going to try to line it up pretty well and then kind of squeegee it down so I don't trap, you know, bubbles or wrinkles and stuff in the tape if I can avoid it. Great. Nice, smooth plastic surface. I'm going to make it nice and very flat next. Alright. So, oh, I should really know how thick this stuff is. I'll measure this other piece that I cut from the same batch. So, not including the tape, this is 0.81 millimeters thick. So, like, the amount we want to take off is probably pretty similar to the thickness of the tape, actually. So, facing at around 0.8 millimeters off the bed, or maybe 0.7, is probably what we want. Oh, I thought the facing plan used to be in that bit breaker menu, but maybe they did move it somewhere else. Maybe I'll have to do a quick web search for this. Yeah, I vaguely oh, yeah, they have you download a G-code. And I guess this just is a facing operation that occurs at z equals 0. So then they have you setting the z to a negative value in order to cut into the machine. So we'll just download that same plan, which is probably, I mean, if this is set up with feeds and speeds for cutting aluminum, then it's probably going to be super overkill for the kydex, but let's give this a shot, since it might be faster than generating a separate G-code that does exactly what we want. Yeah, there used to be a tool for generating the bed facing. I guess they haven't implemented the tool, so now they just have you download its output. So, let's see, the material. Let's just set that to about 140 by, what was that, 140 by 120? And 0.81 is what we said, and this doesn't include the tape. And I'm actually going to take out the width of that notch that I cut, just so the software knows where to put down the tool. So I'm going to just roughly measure that as 8.5. So let's change this to 132 millimeters. And we'll start with placement at 0. And now let's open that facing plan and see what that looks like in here. Yeah, so it looks like that has the tool sitting right on top of the material, which is good. So if we ran this right as it's configured, then it should end up facing, yeah, I was just trying to zoom out. So if we ran this exactly as it's configured right now, it should end up facing it by pretty much the same thickness as the tape, so about 1/10 of a millimeter. So this seems like a good starting point. If it seems like this isn't taking away the texture of the plastic, if there's still any bumps left, then we can bump it down a little bit lower, either by giving it a -Z here or by reducing the thickness. Let's make this an even 0.8 above the metal reference. So if this does turn out to be the height that we end up sticking with, that'll mean that the next layer, which is the Kapton plus Pyralux and some glue, that layer will be sitting right on top of this 0.8 Z level. So we'll know that the top of the surface that we're cutting here, plus the tape under it, which could be whatever size, that added together ends up at 0.8 millimeters. So tool, I think we want an 1/8 inch flat end mill. Let's see if I have a good 1/8 inch end mill for this. I think for a long time the only 1/8 inch tool I had a really long, like a long shank on it before the actual tool, and so I could use it in this mill. It was just very tricky. Maybe it's down here. Don't have anywhere to put this tablet. Eighth inch, where are you? Is this it? I think this is it. Flat 1/8 inch 4 flutes. Cool. That is the thing. Okay. 1/8 inch. I think we're ready to do the tool change. Let's stick this in a bit fan. Wow, this tool is nice and long. This is a good size. Look, it fits in the machine, but it's a good size for it. Oh, I just noticed Mike from Mike's Electric Stuff is in the comments. Hi, Mike. And he recommends using tweezers for pulling back the edges of the tape. I probably should do that. I saw that knife trick somewhere, and it seemed so compelling because it seemed so hard to mess up, but it's also very hard to get right. It's mostly just a strategy for stalling, I think. Alright. Tool is in there. Let's move it a little further down. That doesn't look like it's at a good spot. Yeah, I don't know why that's so far up, but... This is tedious. I don't know whether this is just slow because my computer is super slow or whether it's always so bad. It's like the worst jog tool. I just want to get it to clear that screw hole. Ooh, if I hold it down it goes faster, but that's scary. Okay. A little more, maybe? Alright, let's do that carefully. Great. Alright, let's try taking off some material. Yeah, I can position this a little better now. Hi. Can I not switch cameras while I'm recording video? I guess that would be kind of fancy if it could. Oh, that was the recording button. I was trying to switch cameras. Sorry. Tripod. Okay, great. Start milling. Ooh, this is saying it might take 30 minutes to do the facing. Definitely aluminum speeds. That looks nice. This is not going to take 30 minutes. I don't know what that estimate's based on. I think this is a good depth too. Oh, spammer, sorry. Let me see if I can deal with that. I think they're blocked. Let's see if we can have some moderators. It's making some nice chips. A case where a tool larger than an 1/8 inch would be handy. The spindle, like I don't know if I've seen anybody try to put a larger tool on this. It comes with a spindle for 1/8 inch tools and is probably not super suited for wider tools, except in cases like this, like facing plastic. The plastic that it's milled seems a little translucent, so this might be as thin as I would have wanted to go anyway. From the look of this progress bar, maybe it's actually planning on doing another pass. If so, I'm going to stop it. But I thought this G-code only was set up for a single pass. Yeah, that seems like where I want to stop it. It looked like the G-code might have had another pass in store, but I don't really want that. So, there's our mess. I'm going to do the thing where I blow this out with compressed air and the vacuum and put on my hearing protection and turn off your microphone so neither of us have to hear it. Alright, should be back after the air compressor and all that. Man, so these little Kydex shavings get everywhere. They're super staticky and clingy, and took 2 loads of air to blow most of these out, but still a bunch of them hanging around. Anyway, the surface looks really nice. It's got a nice, flat, sturdy finish, and it's ready to have some awesome milling happen on top of it. So I think the next step is just to do a little more prep on here to put some Kapton on the back and then glue the whole thing down to this nice flat surface that we now have. So I'm going to switch this back to the other orientation. Man, this phone is getting warm. Hi. Something like that. Sure. It's hard to tell that that's still recording, but I think it is. Alright. So now... Ah, what a mess. Okay, I think these are all pretty much the same. Just pick one. And we want to spread Kapton tape on the back of this piece. So I have this super wide Kapton tape for like 3D printing and stuff, and I'll be using some of that. So let me first stick this down so it's a little easier to work with. And this I'm just using the garden variety double-sided tape. So that's just so that we have a slightly nicer surface to work with. Okay, so inevitably when I unspool Kapton from such a wide roll, then it gets a little stretched out right at the beginning. But I think what I want is to lay this down. This isn't going to quite cover the whole thing. I think I can get most of it with one pass, and then maybe use a different roll of Kapton to take this, to get this part. So I want to try to start from one corner and then get it very smoothly applied to the whole surface. Might be getting some very tiny bubbles already. It's possible doing this on the wood is not as good of an option as doing it on a harder surface, but I think I'm getting a pretty good adhesion at least, and I'm seeing some tiny, tiny bubbles, but I think that might be alright. It's hard to tell the difference between a bubble and a dent, or a piece of dust. Alright, I think that's good. Well, let's cover that area and then cut this out. Well, cut it out after adding some glue, maybe. So... I think just before... I forget whether I had to have any overlap. I don't think I did. And, I mean, clearly if there is some overlap, that would be a bit of a height discrepancy. Yeah, I'm going to try to use a slightly more rectangular piece of this, and then kind of minimize the overlap area I have, if I have any at all. This would be easier with differently shaped Kapton tape to get a different roll. Unless there's some under here. Yeah, I'll get some different Kapton. How's the stream going out here? Seems to still be fine. Hello, Kapton tape. This one's kind of wide. Not as wide as that huge roll. So, this is maybe another limitation. It might be hard to get like really high quality results when you're dealing with something wider than the Kapton you have available, since I'm not quite sure how it's going to do across this gap here. Well, when I say gap, I mean slight overlap, which is what we have, which I think is better than a gap. Just saw a bubble that I thought I would poke to see if that helps it not be as much of a bubble. I don't know how much that's going to matter. Okay. So while this is in here, yeah, I'm going to spread some glue down, and then we can just take it off of here and flip it and put it onto the milling machine, and then squeegee it down. And this looks like the corner, well, yeah, there's a little bit of a corner missing some Kapton over there. Maybe I'll put a little bit more on. I don't like these overlaps in the Kapton layer, but I think having a slightly too thick backing is preferable to having gaps in the backing. But it's certainly possible I need to revise that assumption later. Alright, squeegeed. So then I've just got plain old Elmer's glue stick. I think I want a pretty consistent but thin layer. Alright. And I'm just going to cut this out. This knife is maybe not as sharp as I thought it was. Maybe that was part of the problem with using this on the tape earlier. I mean, it isn't super imperative that this all come off really cleanly, but it will kind of get in the way later if it's just hanging out. Might be easiest to use scissors at this point. Copper feels kind of cold from the glue stick evaporating. Alright, and let's cut this corner so that we have a place for the mill to touch down. I think there's enough glue stick on there. Not feeling amazingly confident about the flatness here. These bumps are not great. Like, I think doing some of the earlier steps on this wooden shelf instead of on like a piece of glass. Yeah. I think next time I use a piece of glass or something similarly flat as a staging area. Now this stage is where I really want stuff to be flat. Like, kind of burnishing it almost. There's some bumps over here that are likely to be a problem. So I'm hoping our circuit avoids most of those, but we can cross that bridge when we come to it. Okay. I think that's as attached as it needs to be. So, I think our next step is to very gingerly start decreasing our Z height and milling this until we get the desired effect. So, let's go ahead and do a tool change. Almost feels like I've sort of built a circuit board in the mill, and then I'm going to mill it, and then take it out of the mill, and then it won't be rigid anymore. Oh, maybe I'll see if I have like a really nice sharp 1/64 inch tool to use for this. Yeah, maybe this is something to break out a fresh 1/64 for, if I have one handy. I definitely have some 1/32. Oh, is this it? Okay, let's take the 1/8 inch tool out of this. Ooh, nice. Nice sharp 1/64 tool. Can't blame the tool if this doesn't work out. I think this is a brand new tool. Let's tell the software what's up, and then start decreasing our Z height slowly. Harrowing part of the experience. Okay. So, I'm going to delete this. That thickness of 0.8 is not including our Pyralux. So, I think a very conservative value would be 0.2 for the Pyralux, but let's just maybe measure a scrap of it just to be sure. This is Pyralux and Kapton. This is the square I cut off from the corner. Oh, actually, it's a little thicker than I thought. 0.25. So I think that Kapton is actually a lot thicker than the bare Pyralux. Oh, actually, that was also a layer of double stick tape. If I don't include the layer of double stick tape, then it's 0.14 millimeters. So let's take a look at my notes for settings here. So previously with Pyralux, I was cutting my traces 0.03 millimeters deep, looks like. And, well, it's hard to tell actually what I was cutting because these numbers, I have numbers written down for the thickness of the material I was using beyond the reference, and then numbers for the depth I was cutting. And these are all pretty little. It's like including the squeegeed glue plus the Kapton on the back. I was using a total thickness of 0.05 millimeters and then a cutting depth of 0.03. So leaving 0.02 millimeters behind. Which is much smaller than the number I just measured, which was like 0.15 for the Pyralux and Kapton. But anyway, let's set the cutting depth to maybe 0.03, since that's what I guess I was using. I don't know if that's a real number, but that's at least something to reference the other Z height to. So we'll start with the 0.03 depth, and then maybe add 0.2. So start with a thickness of 1 millimeter, and then decrease the Z height from there. So we're going to open the files the same as we did on the copy of this running on the other computer. I have copper and edge cuts. I guess this can handle the Gerbers or the DXFs. Haven't tried milling a circuit board using the DXFs with the software before. Okay, and then for placement, we've kind of given ourselves a constraint of avoiding this corner specifically, so I think I'm probably going to rotate it so it takes up kind of that diagonal as much as I can, which I think is the same thing we did before. Oh, 45 degrees. Oops. That seems like what we want, as far as placement at least. And then so trace depth and tools need changing. So 64th inch tool. Trace depth was 0.03 in my notes. So let's start with that. Oops. Okay, let's start with just the traces visible. That's all I want to deal with right now. And we want our thickness to be 1 millimeter for this test, which should give us a little bit of headroom. Okay. I I think it's time to give this a shot. A little bit nerve-wracking, but let's do it. Great. So that's an air pass, which is what we were hoping, but just barely, which is also what I wanted. So let's try taking that down by 0.05 millimeters at first. So 0.95, since that should get us close to what I measured with the calipers. Man, I'm really nervous about going down too far, though. This should be fine. It's only 0.05 millimeters. Well, I did see it touch in one spot, but it looks like it's still mostly an air pass, which is good. Let's try 9.3, since we're definitely getting close. I know last time I did this, this was definitely down to the 100th of a millimeter. Seems to be touching the copper more consistently now, but not really going through it. Let's go down by maybe another 0.02, so 0.91 millimeters is our new thickness. Okay, it just barely broke through in one place. Let's go down to 0.88 millimeters, let's say. Very slightly. So it's mostly milling it, but definitely skipping some areas. And so that's definitely because of a flatness problem. But hopefully our flatness problem is not so severe that we can't mill out everything without totally destroying the backing on this board. So I'm just going to go down a tiny bit, 0.87. And anytime I run this and it fails to break through, I'll just go down by 0.01 millimeters. Maybe I should change the camera away from selfie mode since it makes it harder to actually get this framed. Let's also take a close look at what this is doing so far, because it's very close, but it's not quite doing it right. Let's make sure all of this stuff is still streaming. Looks like we're still streaming. I had this live view paused to try to conserve Wi-Fi bandwidth here. Are we still good? Yeah, okay, looks like we're still good. Oops, pause, great. Okay, great. Just wanted to take an opportunity to check that before I get too far into not streaming correctly. All right. There's a lot of this. What is this stuff called again? I keep wanting to call it like Krylon or something. Kydex. A lot of that I didn't vacuum up that was on that side of the plate. So that's looking pretty good. Where was the spot? Oh, right there. Can't really point on the screen. Can I point with this? Yeah, see that? So I'm going to go down a little further to see if I can make it stop doing stuff like that, where it skips the copper. So that's like a small depression where it's a little bit lower, or maybe a gap in the tape or something underneath it. The whole point of having this plastic that I mill flat is so that the tape doesn't affect it as much as possible, though. So let's continue to push my luck, and I'll go down by another 0.01 and see if we can get this calibrated. So that was 0.87. We'll try 0.86 millimeters. Looks good. Oh, this is a little late, but maybe I should start the machine that records the mill while it's running. That is OBS on this computer. Record, okay. I'll at least have a little bit of that is at the higher resolution than what the streaming machine can handle. It also really got dark in the shop. Hey, Tuco. Tuco, what do you want? Do you want to play? Do you want me to turn on the heater? Oh, the heater is on. I can just stand near it. The problem here is not that it's actually cold, it's just that the shop is very drafty. Man, Tuco really wants to play Bolt. Wow. Hey Tuco, I love you, but I'm gonna go back in the closet now. Let's maybe adjust this angle. Oh no. That is going through. It's tempting to leave it going in case this is salvageable. Since, I mean, I could certainly reinforce it with another layer of Kapton on top before even taking it off the mill. But you see that? Then there's even a trace that didn't go through, so I think this is just a flatness problem still. Yeah. Let's stop this and maybe try again, 'cause no point in wasting more of this material. Okay, so this is definitely just a problem of insufficient flatness. Focus. So over here we can see the symptoms of cutting all the way through the Pyralux. And then... And then over here there's an area that didn't actually cut through enough. So I'm going to take off the Pyralux, see how damaged the surface underneath it is, if any. Maybe it's fine, or maybe we need to redo that part. But then I think I'm just going to try taking more care to prepare the Pyralux on a flat surface instead of using just a wooden shelf here. I think that might have been a contributor. So this should come off pretty easily. I don't think we actually, oops. I don't think we marred the surface at all. I think that's all just glue. So no need to redo that layer. We'll just clean this up and put on another piece and try the preparation stages again. And I can save this piece for, like, these sides are still good, so I might still be able to use that for small projects. Okay. I think we can just clean that with IPA. I mean, cleaning it beforehand might have helped also. If there are little bits of like dust and milling debris hanging on it. This machined kydex is a pretty cool look, though. Might have to find some uses for that in the future. Alright. So that seems pretty nice and very, very smooth. Wow. Yeah, that feels great. Alright. Man, maybe for preparation, Oh, I've got a piece of aluminum here. I think glass might be a little better. There's just not so much room to do that in this closet, so it's tempting to go back out into the main shop. So we want uniform capped on. I know I didn't have that overlap before, so... Oh, you know, did I just put this on? Yeah, let's... Sorry, this is not easy to see, but... yeah, I think previously I had this problem, whereas I should really just be doing this. So, maybe let's take this outside to the setup there and do the prep, because I think part of the problem was just doing this without enough kind of space or kind of care. So let's take this and this. Oh man, this phone is hot. And one of these. And let's do this on the desk outside. Oh, Tuco is here already. Hey, little guy. Do you want dinner, Tuco? I think Tuco wants dinner. Let's put these down over here. Oh, it looks like the phone's having trouble streaming. That's interesting. So I'm actually finally out here and noticing the state of the streaming machine. Let's reconnect that. Hey Tuco, what's going on? This is acting like the, what are those things called? The Chromecast is hung. Hey Tuco. Okay, yeah. Hello, Wi-Fi. Maybe the phone has problems with Wi-Fi when it's superheated. Anyway, I was trying to change channels, and of course I reached for the thing that is currently not working for reasons unknown to me. Hey, Tuco. Alright, it so happens I already have a piece of glass here on the desk because I like having a flat work surface for other reasons. This tablet is, or this phone is still having lots of trouble connecting. That's a nice picture, but it's not mine. Okay, I'll worry about that in a sec. Let's try to do the actual prep here that I was talking about doing, now that I have the big camera set up and all that. And Tuco, you're so in the way. Oh. Are you sure you don't want to hang out on the graph paper? Okay. Oh man, do you ever have deja vu but for smells? Like you're just kind of out of the blue remembering a smell for no reason? I thought I smelled like a really strong red wine for some reason. I don't think I have any wine, like at least no bottles open right now. I guess it theoretically could be the neighbors, or it could just be my imagination. Let's try not to lose these buttons. Oh, let's also try not to let this be hair cam. My haircut is currently not nearly interesting enough to have a camera dedicated to it. Okay, let's clean this plate a little bit and then use it as a squeegeeing surface. I really don't want to hit Tuco in the face with my elbow while I'm doing this. Okay. All right. So let's use... Man, even holding this down is a little bit tricky, but I think just putting a little bit of tape on the top side is what I want, just to keep the bottom as flat as possible. And I think I just want to anchor this on a single edge, the edge that I'm squeegeeing it from. This doesn't need to be double-sided tape, even though it is. Okay, maybe let's not even worry about holding it down. Once I start actually applying this, I think I'll have different problems at that point. Maybe I'll start by tacking the Kapton down to the glass and then slide this underneath and then start squeegeeing. Oh, I left the chat laptop in the closet, so I can't see what people are saying right now, sorry. So, I think I want to start with a point in the middle, probably, and then try to turn that into a line. Oh geez, don't stick that much. Well shit, that's not what I wanted. Okay, I'll start with the corner then. Let's make a cut. And so I'm just making a tiny slice here. I'm going to try to get it to tear relatively straight. And now I think I'm just going to try to get it to stick somewhere and then just go with it once it sticks. I need a little bit more working room on this glass. There's probably some machine that would make this super easy. Okay, so I think I'm starting with a single point that I'm adhering in the middle, and spreading that outward. Oh, I've got wrinkles. That's no good. Can't have wrinkles in that. Oh, geez. This would definitely be easier if I had Kapton that was a little bit thicker. I mean, not this Kapton, but the Pyralux, if that had Kapton on it that was a little thicker. So I think what I want is to really make sure that this is not curled in the wrong axis when I drop it down. Okay, that's a better start. Oh, that's a huge bubble. Let's not have that. I'm sure, like, this is probably like 90% of why I'm making this material in the first place. The Pyralux is actually difficult, is getting it to be really flat and bonded nicely. Oh, this is not really working. It is adhering too much in the wrong places. Man, how did I do this last time? It was certainly a smaller circuit that I was working on. So worried about inserting additional wrinkles into this while taking the Kapton off too. This was also not the right side. This would have been a fail in many ways because I want to be putting this on the non-conductive side. Oh, Cat does like the graph paper, I guess. Okay. Can I maybe hang it on this top edge of the glass and then put it on my desk? So that helps. Still got air bubbles. Those are not nearly good enough. Yeah, that really wants to make dents in the foil too, which is probably not going to help later when machining this. None of the dents look very spiky. Here, I'm going to try using this same material. I think it's stretched out a little bit, but not too much. Looks like there's still enough kind of small bubbles in there that it's not getting as flat as I think it needs to be. Alright, maybe I do need a fresh piece of Kapton. Not sure where those bubbles are coming from at the beginning there. I wonder if that's unevenness in the surface of this Pyralux now that I've been mangling it a bunch. Or if it's just... Because I think a lot of this problem is that it wants to develop wrinkles right near this edge that I've anchored it on. So I need a way to get the wrinkles out without affecting the thing I'm actually trying to cover. Maybe that's what I wanted to do. Oh, don't stick yet. Don't stick yet. Still a bubble. I think this is better, but that's still trapping air bubbles. I'll borrow somebody's clean room to do this part. annoyed and sloppy at this, which isn't helping. Hey Tuco, what do you think about Kapton tape? Like, I really like this stuff. It's just getting any like films to stick together without bubbles is super annoying. I mean, I think I want a way to anchor this down starting with just a corner. Maybe there's a way I can use some tape to hold this in place, but then remove the tape before I have to put the Kapton over that portion. Ultra Electronics Crafting Show. I think that bottom corner is going to want to stick first. So far, so good. Can I get a better view of this? Okay, I think this is working. I think I just was trying to hold too many things at once while this needed to get started. Oh, tiny bubble. Let's not do that. Can I undo that bubble? I think so. Yeah, great. Okay, I think I can take out this tape carefully. I kind of want to adjust the camera, but I don't want to stop holding this. Okay, this is going alright. A little more of this, and we'll have the Kapton coating the back of this Kapton and copper sandwich, and it should still be flat. Oh shit, I might have just done something bad. Let's try to not do that. Oh, I think I made a tiny bubble. Let's not do that. Oh man, this is sticky. This is so much harder to work with when it isn't anchored to the glass. I guess I should anchor one side still. Oh man, I really don't want this Kapton to get messed up. Ooh. Okay. I guess while I'm no longer holding it, I can also adjust the camera. Guess we've got some blue tape under the microscope. Alright. Yeah, I think part of the reason the tape is necessary is to help keep the two layers separated when I'm not actively trying to stick them down. Because I think otherwise the Pyralux is just so light that it just kind of wants to float up toward the tape and then it gets stuck. I'm getting a little ahead of myself here. A couple of little bubbles. So having better flatness should make it easier to cut through consistently without going quite as deep. And then the less deepness is what we need to avoid just completely cutting through like we did on that earlier attempt. This is still not going to be perfect. I guess the trouble with having not done this very many times is I don't know how good this actually needs to be, but I think it needs to be pretty good. Moments like this, I kind of wonder why I ever build anything. Because I don't tend to like projects unless there's something in it that offers this element of, you know, I don't even know if I could do that. That's something new, you know, it's kind of a challenge, you know. But then I end up in situations like this where I've very little idea of whether it's going to work out, and I could really use that you know, that feeling of having a project work out successfully, but, you know, it wouldn't really mean much if it was a project that I that didn't have any, any risks to take or anything new to try. Oh man, I think I'm getting a little sloppy because my wrist is getting a little sore from that position. I wonder if I can turn this around. How's the cat? I think this tape is not helping anymore because now it's just holding it into a position that isn't even correct. Oh. I needed something, I guess. I guess painter's tape does not stick very well to glass, who knew? Oh, come on. Yeah, those layers need to stay separated until I get there, or they just stick in totally the wrong way. I think I've got something. Oh, something felt kind of gritty, like there was something under the copper. I might just be imagining textures. Oh, that is... Oh, movie recording stopped. Whatever. So about this much of it is great. That is still kind of a mess. Oh, jeez. Oh. Okay. I think that's back to where I wanted it. Let's try to glue this, or tape this down slightly better. I mean, maybe I want to be using Kapton tape for this, but I want to make sure I can get it out easily later. And these bubbles might be bad, but they probably won't be as bad as whatever was up last time, which I think was from just working on a bumpy surface. It might still be a problem though. Yeah, making such a large, oh man, making such a large piece of this is definitely harder than making a small piece. I think it also might be easier to work on a piece that's a little bigger than what you actually need and then cut it to size. Which, I mean, is kind of the case here because the piece is kind of a diagonal coming out of this, but having some edges to grab onto it by would be kind of nice, maybe. There's still some bubbles in here I don't think I'm going to be able to get out, but I'm running out of patience for this. I'm going to at least try to puncture them so I can smooth this down on the build surface. Yeah, this is not amazing. You know, I bet this would be much easier if I had some kind of solvent I could use to put this down wet so that the adhesive wouldn't stick until the solvent evaporates. I'm just looking for a knife to cut this out with. Alright. I don't feel super confident about this, but I think it's ready for another shot. It's not showing evidence of being extremely flat. Let's see what we can do. Oh, maybe switch this to the right channel before I leave. Camera. Man, this phone thinks it's still connected to be mirroring, but it really isn't. Maybe this phone is confused. Maybe I'll restart the phone. Oh, it's nice in here because I've got a view of this very nice machined surface, which I will get back on the camera as soon as the camera boots. Okay, need to get this remirroring. It's all like, your phone needs a SIM card. And I'm like, I know. I don't need... trying to set up the screen mirroring, and it's in like the Google Home app, which is just full of stuff that I don't care about. There we go. Connecting. I was trying to monitor the stream from in here, but... Alright. That seems like it's probably fine. Technical problems. Okay. I'm going to see if I can choose the best orientation for this that avoids as many of my mistakes as possible. So I think I want to lay it like this. So I'll cut a little notch in the corner to match. Okay, so now I'm just going to glue stick this down. Assuming I can keep the camera out of the way. Okay. That's somewhat uniform and very sticky. It's a little easier than the adhesive on the Kapton, since this stuff can kind of wiggle a little bit once it's down. And definitely seeing a couple of places where there are visible bumps, but if our luck holds out, those will be minor and we can mostly avoid them. Haha, luck holding out. That never happens when you're making things. Things always go wrong. For example, this is a little farther from the left side than I think I would have preferred, but I think we have enough margin to take that into account. Oops. Yeah. I think we're good. So let's start with a somewhat higher Z height. Let's maybe go up to 0.9. Oh, did my camera lose its connection again? Sorry. Let me try to get that to reconnect. So I don't know why this keeps ending my screencast. I guess I could be running low on Wi-Fi. Okay, so 0.9, 1/64th, I think we're just ready to hit go, and then smidgen this down until we hopefully get the cuts we want without the cuts we don't want. That is just very a little bit too high. It looks like the screencast ended again. Let me see if I can get that back. So we've got a bit of an impression on the copper, but it's still too high. So I'm going to inch this down very tiny bits. So we're at 0.90. I'm going to go to 0.89. Just take this really slow. Still a little too high, so 0.88 now. So I can see one trace that it skipped, or one area where it was not deep enough, but I think it might be close enough that I'd like to keep this going and see how far it goes, because if there are only a couple of little problems like that, it might be worth just fixing them manually. I was just checking up on the chat very quickly, and I noticed the soapy water. Regular plastic film. Yeah, that might be a good option too. I mean, yeah, I think there's a bunch of things that that people were mentioning on the chat that I probably will try next time. The larger piece and having some tape on the edges to help with hold down, definitely. And yeah, I like having the Kapton on the back as a backing material, but I could certainly apply that later, and it doesn't need to be as perfect if it's done after the milling is complete. Oh, I'm seeing a couple of potential showstoppers here. Like there's some long traces that aren't milling through. And then in the top right, it looks like it might have cut a little too deep, but we'll see. Yeah, let's stop this and take a closer look. So, yeah, so we've got some stuff like that. It's not quite breaking through. And then I'm a little concerned about this area in the back. Because it looks like it might be kind of blowing out through. Well, I guess I can just touch that and see. Well, yeah, it's a little rough there. It's hard to tell if it's coming apart. But there's so much of this that isn't cutting through that I might bump it down another 0.01. I would actually go even less, except 0.01 is the smallest I can move in this software. I would actually like I know the stepper motor has more resolution than that. It would be really nice to have access to it for projects like this. All right, going from 0.88 to 0.87. Let's hope this doesn't break everything. lot of this part's going to be repetitive. Tuco's still hanging out here on the graph paper. Oh, cool. Another piece of advice I'm noticing as I catch up on the chat is to use some heat. So to use spray adhesive, and then use a heat tool to soften the adhesive while I'm putting the copper down. That's pretty nice too. Yeah, definitely several people have suggested it'd be nice to have the chat make like a ding or something when people say my name. And I think part of the problem could be solved technically, and I think part of the problem is just that my attention is split so many different ways when I'm doing these streams. I think the way I tend to solve problems, I get into such a tunnel vision that, you know, I don't tend to check other things unless something kind of pokes me. But yeah, maybe there's like a pager I could wear or something, so even if I'm not like next to the chat computer, it could like vibrate in my pocket or something. Oh, another suggestion I'm noticing is whether you could run the Pyralux through a vinyl cutter. That's a good idea. I do have a vinyl cutter. It's not a great vinyl cutter, but one thing, I think it's probably strong enough that, like, I'm imagining if you use the vinyl cutter to make like cuts on either side of a copper trace and then maybe just like peel it off with tweezers, kind of like weeding a piece of vinyl art. Oh, you know what? I think I'm going to go down slightly more. I'm just taking a closer look at this, and this is having, I think this is basically the same problem. So I don't see anything that's definitely cutting through, but I do see a bunch of places where it could use a little more depth. So let's go from 0.87 to 0.86. And try this again. And that's interesting. A suggestion to use yo. I didn't know that was still a thing. Use yo to ping me when someone has a suggestion. I think this might still want to go down a little lower. This didn't seem to help with the problem areas. Or it might just be that's what these are, problem areas. And, you know, like I pressed a little too hard and squished something lower than it normally would be in those areas. Yeah, the coverage on this is just still so spotty that I'm going to go down a little more. Might regret this, but it's just skipping a lot of copper. So 0.85 is next. Oh, that cleared one of the traces it was having trouble with before. Yeah, so far so good. It's getting through the areas it was missing before. Doesn't seem to have broken through yet. It's not perfect. There's one it missed. But if it's just missing like one or two areas, that's fine. I'm only going to move it down again if it's still missing lots of traces. Yeah, that's still a pretty long when it's missing. Yeah, okay. I'm convinced I should go down a little more. 0.84. Let's try 0.84. Wow, this phone sure is getting hot. Yeah, that was another kind of medium-sized one that it skipped. All right. There are enough small ones and a couple of large ones that I'm going down a little more. I mean, ideally I want it to mill the whole board successfully in one pass. We're just a little bit shy about breaking through the Pyralux at this point. Let's try 0.83. Got a good feeling about this one. 0.83 millimeters. I keep expecting this camera to shut off at 30 minutes also, but I don't know if it does that. Yeah. Small gap still, but that might be the first one I've seen so far. This might be pushing my luck, but I think I'm going to go down one more. There's a couple of long tracks that it's still not quite cutting. Can we try 82? Are we gonna destroy it with 82, or is this gonna be amazing with 82? .82 entire hundredths of a millimeter thick. Oh, and from chat, Wildmania is asking, can I mill separate parts, just the parts that have been missed? It's not easy to do that. It's certainly theoretically possible to go in and, you know, grab just part of the G code. There might even be editor tools that make it a little bit easier to do that, but it's not really normally part of the process, so most tools won't really do that on their own. Like, I think this little thing that's on screen, the kind of pause play thing, like, that lets you pause it, it lets you stop it, but you can't, like, fast forward. I mean, in general, if you're doing that kind of a milling operation where you expect that some milling has already been done and then you're doing additional milling, that's a thing that's not uncommon, but usually you have to set that up in the toolpath generation software rather than doing that later on, since, I mean, I think part of it might just be how the software happens to be designed, but I think it might also have to do with, you know, you typically want the CAM software, so the software that's making the toolpath, you want that to be validating that you won't hit the toolpath on material that hasn't been milled yet or anything like that, and it's hard to do that. Like, that's work that you really need to do in the toolpath generation software rather than in the relatively, you know, the relatively ignorant software that runs the actual hardware. There's also a question about why I'm milling this instead of chemically etching it, and it's because I have the mill and I don't have the chemicals. That's pretty much the reason. It does seem like this would be easier with chemical etch. I am interested in experimenting with, whether there might be some techniques that milling enables with this sort of material. Like, I like the idea of making some kind of laminate with Pyralux and other materials, and then milling it in a way that adds traces and mechanical features. I don't know what, whether that might actually be useful for something that just making the circuit board separately with chemical etch wouldn't. So I don't know if you can see it on the camera, but there is still one little skip left. But that's small enough, I'm just going to take care of it with a knife if that's all I have to worry about. Oh, I think there might have been a skip in the audio during some of what I was trying to say. So as for milling versus chemical etching, I think this particular board would be much easier to do with chemical etch. It's just I'm using the tools that I had handy. Oh, and then I'm also interested in maybe some, doing something that milling would actually enable with this technique. So something where you make like a laminate material, so involving copper, maybe Pyralux or maybe just bare copper sheet, and then maybe other kinds of plastics or resins, and then making something which is a combination circuit board and mechanical piece on the mill. So I find myself kind of curious about whether there might be any interesting niches for that, like something where like really good registration between the circuit and the mechanical surroundings could be really interesting, or maybe just a method for doing kind of flex rigid PCBs at home, where you do this kind of milling on one side, then flip the whole assembly over, then mill pockets on the other side. It is so tempting to bump this down just a little bit more. Since there are a couple of places that it's not cutting through. And like enough that it would be annoying to cut out that entire thing with a knife. I'm going to pause this and show you what I'm talking about. Well, stop it, rather. So a lot of this is doing fine. Like, lots of this is great, but that is not so good. If that was the only problem, I would fix that by hand without fussing with it too much, but this one up in the corner, that's annoying. I think I want to have the machine deal with that. So I think the easy solution there is to bump this down another 100th of a millimeter. Man, I might like start to worry about burning myself on this phone. At least it's not a Note 7 or whatever. So 8.1 millimeters, can we do 8.1? Will 8.1 destroy this circuit, or will it be the perfect height? I kind of want to get this phone on the thermal camera. I definitely think multi-layer flex would be in the cards if I had a better way of kind of controlling the height and putting things down smoothly. In the past, I've done multiple layers with, you know, cutting one layer of flex on the mill and then just adding copper tape by hand afterwards. But this would certainly be nicer. See, we're all afraid of failure, but I'm also afraid of imperfection. I mean, that area where it was just not cutting through on the kind of top right, that would probably be something that wouldn't take too long to clean up with an X-Acto knife and a microscope. But having such a large area not cut through seems like reason to adjust the process rather than work around it. Oh, I think I have a non-contact thermometer in here. Hard to get the back of the phone while it's pointed at the mill, but I think it was something like 36C. Oh no, like 40C. Oh, there was a comment in chat about applying resist using a wax printer, which sounds pretty cool. That also, I'm also kind of curious, like I don't have one of these, but like a kind of a writing style plotter, like, oh, I'm spacing out on the name of it, but it's a new thing that Evil Mad Science does. That's like a pen plotter that holds like a fountain pen or whatever else you want to use. And it's really cool. It seems really rigid, and I'm wondering if you could put some kind of resist marker in there and then just stick a PC board in there. Well, so far, this cleared the area in the bottom I was worried about, and it hasn't broken through on the top right yet, which is one of the thinner areas so far. Oh, there's still a skip up there, I guess. All right. Well, I don't think I'm going to go any lower than this. I'm curious what happened up there to cause a bunch of traces to be missed, but I think we can deal with that in post. Wildmania Unchat suggests exploding the unused or the extra bits of copper shorting out the between the traces just with low impedance power source. Oh man. I'm still so unhappy with that area though, because it's like not just a single straight section, it's like an entire surface mount pad that isn't milling out. Yeah, I don't remember the lumpiness on this being quite as much of a problem. I think I might have just like handled the piece of I think I might have just handled the piece of Pyralux a bit too much and crinkled it. So I'm gonna have to try some of these suggestions for bonding the Kapton a little more effectively, and you know, like I'll try a solution of soapy water or alcohol and water and see if any of that helps. Might just try to see if I can make the situation a bit less mechanically annoying, because there were just way too many things to hold. I'm also curious what kind of defect we're going to see under the part that didn't mill in the top right. Like if that was, maybe that's a spot where there wasn't tape under the, like under the Kydex plastic. So, you know, one source of problems would be just bumps in, like in the Kapton plus Pyralux layer. But another problem potentially would be if that plastic support under it that we milled flat, if that's actually sagging. Which I don't think it would, but like if that does turn out to be the problem, then the solution, I guess, is a thicker backing layer. So using like the acrylic instead of the Kydex. What was that sound? All right. What's the damage? So there's one right there in the middle that didn't mill horizontally. And then this little group over here. So it seems like maybe this is stuff that's worth fixing up on the bench. It would be really nice to get all the way through on the mill, wouldn't it? I wonder if I can tell how much I have left in these cracks. Like if I can feel how deep they are with a knife. Man, that is very shallow. Yeah, I don't know. I don't know whether to do it here or on the bench. Like, doing it on the bench is more likely to succeed. but like having a process that's more repeatable is in some ways more interesting to me. So I don't know, like maybe I try lowering it a little bit more, and if that still turns out to be problematic, then like I think what that tells me is that like there's this critical inequality where the flatness of my surface needs to be, you know, enough less than the thickness of the copper I'm milling through. And so the copper is actually most of the thickness of the original Pyralux, and then the sandwich of Pyralux plus an extra layer of Kapton is probably like twice that thickness. So all right, well, I think I'm going to go down another 0.01, because this stuff over here, I don't want to have to do that by hand on the microscope. If that doesn't mill out, I think it's just means change the process and start over. Oh, that was a cool suggestion. In chat, US Water Rocket suggests maybe there's a kind of like copper clad where it has a dissolvable center, so I can like mill the top and bottom. So maybe I would mill it and then like glue some more Kapton on the top after milling it, and then dissolve away the bottom. That would be interesting. Okay, so that was 0.81. I'm going to go down to 0.80. You know what 0.80 is? 0.80 is the height of the actual layer of Kydex plastic. So I think if I mill to 0.80, I will definitely go through. In fact, with a trace depth of 0.03, I don't know why I'm not already going through. Maybe the thickness of the glue? You know, it's also possible I used too much glue stick. That might be part of the problem. Definitely seems worth experimenting with spray adhesive instead of glue stick next time. But so I think there are a couple of sources of inaccuracy, and 0.80 here isn't necessarily as deep as the piece I faced, but in any case, another try going slightly deeper. And let's see what this gets us. No signs of immediately destroying the board. I really want to know if that area in the top right is going to be all right. I have to wait for it to get there. think one other reason why it'd be nice to get all the traces milled through on the machine is that I'd prefer to put another layer of Kapton on this before even removing it from the mill, just to help with strength in case this is cutting most of the way through. So that gets more complicated if I also have to do trace fix-ups. I either need to put the Kapton down now and then, I'll have to uncover the locations where components go. And so I'd also need to uncover any traces I need to fix and then recover them if I want. I could also try to fix them while it's still on the mill, but that seems annoying. I think mostly, though, I just don't want to have to be fixing individual traces. I want to get the milling process. Nope. All right. It just skipped right over that area where I was hoping it would mill. That just looks so close to breaking through over there. I mean, not like through the board, but through the copper, where I want it to. Oh, 0.79, do we dare? Do we dare to dream about 0.79? This is really an area where it would be nice to have more control in the software. Oh, I think my phone just ran out of batteries. I'm going to start this milling at 0.79 and then go out and maybe put some batteries on this phone. Yeah, the Pyralux and Kapton is currently glued to some plastic, which I thought I was going to use acrylic for this. I ended up using this KiCad+ stuff because it was a little thinner and I had more of it in the right shape. This phone is so warm and probably out of battery. Yeah, it would help if I grabbed the right kind of charger also. Oh, the warm phone is actually kind of nice out here. Cold in the shop proper, but kind of nice in the machine closet right now. Hey, Tuco. I think this phone is in the state where it doesn't want to turn on until it's charged a little bit. Yeah, this phone is not so happy. I think I need to let it charge a bit before I can actually stream from it. I guess next time I do this, have a battery pack for the phone. Oh yeah, I definitely, the suggestion from chat from Sodium, I definitely could just take the entire Kydex board out and then fix stuff, and then capped on it down. The only reason to leave that in there is if I'm going to mill additional flex boards, then I can reuse the setup, but I certainly could take it out, and that might actually be the easiest thing to do. Oh, and another nice tidbit from chat from Len, that apparently Kydex is an acrylic PVC composite. I did not know that. All I had remembered about it was that it was good for vacuum forming and fairly flame retardant. I was mainly looking for pieces to use for a lighting project, so it had to be easy to form and not likely to sustain a fire if something like that happened. Oh, I think we're good. Looks like it just cleared that area I was worried about. 0.79 might be the number we wanted. Oh, yeah. That's like butter. Just cutting right through that copper. That's so satisfying to see that tiny little 0.01 millimeter sliver of copper disappear. Well, not quite, but it's gotten it to a point that's actually pretty easy to fix by hand now if I need to. Yeah, in fact, I think it's actually the way it's, the particular part of the trace that it missed is actually not electrically important. Somebody named Wexo is asking if I actually read chat comments. Does that answer your question? I don't always keep up with them, but when I'm not distracted, I try to. Oh, another comment on a conductive inkjet printer. Anyone? There are definitely a lot of doodads I've seen recently for making circuit boards, especially with various conductive fluids that they squirt out. I don't know. For a lot of things, that kind of a technique is like, I don't know. The main problem with it really is, like, at least as far as I'm aware, is like durability and resistance. But for something like this that isn't necessarily going to move around that much and is just buttons anyway, then yeah, it might be doable for something like this. It might also be worth taking apart. So I think I mentioned a little earlier that, I have like a little numeric keypad, that I'd been using to change channels on the stream, which is what this is intending to replace. And I had taken it apart just to see if there were opportunities to mount some magnets inside, and it actually had kind of an interesting construction method, kind of a very, very cheap way of doing a flex circuit board and then bonding it very loosely to a circuit board that had, I think, carbon plating. So it was all, instead of like a metal where you need like a precious metal or it's going to corrode, they took advantage of just carbon plating everything. So the carbon, never is a great conductor, but doesn't corrode and become a terrible conductor over time. All right, I think that is a better state to be in. Oops. All right, I wish I had the little portable camera to show right now. Let me actually maybe go out and see if its battery is enough that I can at least bring it in here. So also I'm noticing I've been streaming for like almost 6 hours, so I think it might be good to wrap this up a little bit soon. I think maybe the stopping point I want to get to here is to get this flex circuit off the mill and get it ready to populate, but not necessarily do the assembly tonight. So I think mostly the steps remaining are to kind of, clean this off a little bit, put down some more Kapton, and then, actually, I could put down that Kapton before or after doing the. I was about to forget the whole outline milling step because I was so excited about the traces, but we do actually need to cut this zigzag out as well, and I definitely want to have the top layer of Kapton on before I do that. So yeah, let's put the top layer of Kapton on and then do that milling operation. I think this phone is gonna hold. It has just a little bit of battery, but I have it plugged into a little power bank here. Are we casting? Every time I boot this phone, it's like, you need a SIM card to use this as a phone. And I'm like, I am aware. Unable to use flash because your battery level is too low. Great. Let's see if I can still record. Okay, well, it's recording locally, and hopefully it's also casting. So this is what I'm at so far. It still has this one little area where it hasn't quite isolated that pad, but electrically it's probably actually fine since that wider island that it's near is electrically isolated from everything else anyway. And then I think everything else actually milled fine. There was an area over here that I was a little worried about, but I think that actually cleared up. So I'm going to blow this out with the compressed air, put down another layer of Kapton, which doesn't have to be quite as careful as the previous layer since it doesn't need to be super flat. And then do the outline, and then we can take it out of the machine. All right. I guess I need the vacuum for this. I will turn off my microphone to spare you all from the noise. Alright, we'll be back with audio. Was picking at this area over here because there was a very, very tiny piece of copper that I was trying to get out before I seal it in there with the Kapton tape. And there's still some of this like fuzzy stuff. I think most of that is some like bits of the Kapton that kind of came up during the milling operation. So as long as it's not conductive, I'm not super worried about it. Oh, my Kapton is outside. Let me put the T outside and bring the Kapton in here. Hey, Tuco. Tuco's hanging out in the hallway next to the closet. Oh, Kapton. And then we can do some more milling and then wrap this up. Because it is time for some dinner here, I think. Going right from breakfast to dinner. It's that kind of day. Oh man, this still needs so much more cleaning. Okay, maybe... I just don't want, like, plastic stuff sealed in the Kapton layer, so I'm going to see if I can get more of this out. Plastic is everywhere. Like it's on the camera, it's on the board. Yeah, it's fine. it will gradually become less of a force in this room as I get more of it up. I see a couple more little annoying threads of copper. I'm going to grab some tweezers because those are otherwise going to turn into some terrible solder bridges later. So I see, like, that one was no good. That's just lint. Man, yeah, this plastic is just everywhere. Maybe this can hang out over here. This stuff sticks so immediately to everything. This top side is not going to look as good as the bottom side. Oops. Try not to destroy the camera. You can tell my patience for applying layers of things is not quite what it was earlier this evening. Alright, I'll squeegee that a little bit and then do the outline cut. And I might need to excavate parts of this to do repairs or check for shorts, but having most of this layer in place right now seems super useful for mechanical strength. I don't think I got much of that black plastic under it, but there's probably some. Or there's definitely some. So, let's just trim the other side here. Okay, so I think I'm going to use the 64th still for this because the material is just so thin. The 64th inch should be fine with it. Changing the Z height from 0.7 down to, well, I don't want 0 because that's like through all of the Kydex layer. I want to go maybe a tiny bit into the Kydex. So let's maybe set the thickness to, well, okay, so thickness is what I actually want to cut through. The Z height, because this is going to work a little bit differently for outlines versus traces. So I think the thickness should be something fairly conservative, like, or in the up direction. So this will be more than our actual material. So let's just tell it the material is 1/2 millimeter thick. And then placement is how far down it's going to go. And so I wanted to go through all of this material and maybe a little bit into the Kydex sheet. So let's just say 0.5 to give it a pretty good margin. Yeah, let's make this thickness 0.8 and the placement Z 0.5. And that's the weird snaky shape it's going to mill. So I think that's all. Let's put the window back on. I don't know where these time estimates are coming from. This is saying it's going to take an hour, which is way longer than this is actually going to take. Maybe it's going to take an hour because this thickness of 0.8 is enormous compared to what this can actually handle and what it needs. What is our step down here? It's not going to tell us the step down in this particular part of the tool. Let's just change that to 0.3. I think this is also maybe not the right tool for the job. Like, I think I actually want to be using my 1/32 for this, because a 64th just seems totally overkill for cutting out the outline, and like I'm just going to make this tool duller than it needs to be. And a 32nd inch tool should be able to take more material off at once. And I don't actually need sharp corners for the outline. Alright. And let's make the thickness 0.4. Sure. Okay. I like that a little better. Let me do the thing where I put that on and then do the tool change. Where's the cover for this mill? Don't like losing the protective covers for these tiny end mills. Oh, there's my 32nd. Still don't see the protective cover, but I'll just try to be gentle with that until I find it. 1/32. Locating the tool. It's looking good. Well, that's exciting. Nope, nope, you're already cut through. No need to continue. All right. Yeah, that was fast. Left a bit of a gnarly edge on that Kapton, but I think it'll be serviceable. Well, I think we've got our flex circuit. At least, you know, pending a little bit of cleanup and assembly. And, you know, designing the rest of the enclosure for it and stuff. So... There's a tiny piece of Kapton that didn't cut all the way through because it didn't have anything under it to act as a support. Oh, everything's running out of battery. My, the laptop I have the chat on is complaining also. Something more spatula-like than tweezer-like for that. That is our very thin circuit board. Great. Let's see what is left on this build surface. A little bit of plastic from this digging in on the edges. This does seem like it doesn't necessarily... I don't know, like, I think this might be having some flatness problems, because I would have expected that last pass to cut in to the same depth all around here, but it cut in kind of significantly here and barely touched it over here. So, wondering if maybe this plate here ended up flexing somehow, or I mean, it might have also been something with the milling machine. Like there are ways to get the machine out of alignment, but I don't think I made any of those mistakes this time. So I'm not going to bother leaving this on since it's not the best surface for this, apparently. Also, I guess the tape doesn't really stick to this as well as it sticks to the aluminum. Alright. I mean, there's still plenty of this material left. I wasn't in danger of cutting through it even slightly. I was just barely taking the face off of it. I'll have to work on that for next time. Anyway, this is what we got. It'll need a little bit of cleanup, obviously, but let's I'm gonna take care of cleaning up the mill later after I end the stream because that's not super interesting. Let's just take this back out to the desk and give it a quick once over and take a look at it. But then I'll probably wrap this thing up just because everything is running low on juice, including the human and the cat. Oh. It is flexible. Hey, Tuco. Excuse me. Tuco, do you want food? I'll make some dinner in a sec. Okay, feels nice to be back out here. Let's switch cameras. I'm still covered in plastic. Alright, so here's what we got straight off the mill. Got these really ugly edges where the, I guess apparently not so sharp 1/32 inch tool tore up the Kapton. Hey Tuco, I hear ya. But that's what we got. So, you know, some cleanup, and then cutting away the Kapton like right over where the switches need to go, and then putting those in there. And then of course there's this whole separate part of the project involving designing the 3D printed part that goes on this. But yeah, that's pretty much it. Let's see how it looks on the actual pole where it's gonna go. Hey cat. So it'll be somewhere like that. This would kind of wrap itself around with magnets and then have like a wire tail coming down. And then I would just like press these buttons to switch channels. All right. Well, I think that is about a wrap today. Thanks everyone for tuning in. Certainly another bit of trial and error and some things that could go differently next time, but I think I learned a lot, and maybe some of you got inspired to try some new circuit techniques. This is definitely going to be more flexible than if I used a rectangular piece of the stuff. Alright, well, I will get this wrapped up, and I'll see you all on the internet. Definitely let me know what you think. I will try to announce the next stream on Twitter as soon as I know when it's going to happen, but I also I do the announcements on YouTube, so if you sign up for their notifications, then it'll let you know when I'm going live. All right. Happy hacking, everyone.